Hello everyone and welcome to the C++ 101 class and introduction, and your lead instructor will be Mr. Nelson LeKay. Welcome, Nelson.
Hi.
Hey. So this is the start of an 8-week C++ introduction course. It is a course that is designed for beginners, complete beginners. Now I see a lot of people over in the IRC that have been using C++ for some time. Please keep in mind this is a complete beginner course. We are not targeting you guys. We need to make sure that our questions try to stay as focused as possible on beginner C++ content. To be more specific, the content that we are covering in the class, because the last thing we want to do is scare off our complete beginners. We will be hosting this class again this coming Friday, and this is a free webinar that is open to any and everyone that is curious about how we go about doing our classes. After this week, we will then be proceeding into our regular C++ classes with week 2, 3, 4, 5, 6, 7, and 8, and those will be member sponsor only. Again, for those of you that are member sponsors and you are taking this course seriously, remember, we do invite you to join us for both our Monday and Friday sessions. Now, it is very difficult to accommodate everyone with their time zones and all, because we have people in the class from all around the world right now. So we do the best we can. We're having the class twice a week. We're going to be doing it on Mondays at this time here, and then we'll repeat again on Fridays at the time we normally would do the 3D Buzz radio show. So that would be 7 p.m. Central Daylight Time. So you'll be able to find that information in the live classes calendar. Also, for those of you that are joining us for this class as member sponsors, starting next week, there will be a new password issued for each class. It is issued within 5 minutes of the start time. And Nelson, if you could real quick, bring 3D Buzz back up and show them where they will be able to find passwords.
Yeah. All right. Passwords are going to show up in the live classes calendar. So that's going to be up there at the top called live classes. You click on that, you get this nice little calendar. And so, for example, if this class had a password, you'll see that the day is highlighted right now because it is the 9th. Simply click on that and you will get a password link here. Or not a password link, a password here that you could use to join the webinar. So that's going to be posted in this calendar system.
And it's posted within 5 minutes of the start of the class. So please just make sure you go there to check as class time is about to kick off. And you just might have to refresh the page a couple of times or just wait till start time right on the dot and check it and you'll find it there. Usually we don't get things going in the class until about 5 minutes after the hour or the start time, just to enable those that are coming in a little late to get in. So yeah, I wanted to make sure we covered that. Also, we will be using the BuzzNet chat system for our classes, and that will be found. You just go with a web browser over to buzznet.3dbuzz.com, and you log in with your regular 3D Buzz credentials. And again, that's the system that is required. Everybody needs to use that when doing the actual classes after this week here. Let's see, Gav, yes, I just saw your question about adding you as a panelist, and I'll go ahead and move you over real quick. There are a significant number of people, so it takes me a second to find you. There you are. Wow, that is a lot of people. Okay, fantastic. So with that, there is one period during this class that will have a down week, but we'll spend more time talking about that next week when we get into the specifics of the class for the remainder of the time with the member sponsors. So Nelson, let me go ahead and hand it on over to you, and let's get things going.
Okay. So, yeah, we're going to learn C++. I mean, are we just starting?
Yeah. Did you want to go ahead and start by asking people about what operating system?
Yeah. What operating system are you guys using? I assume most of you guys are going to be using Windows. So if you're using Windows, don't post. But if you're using, okay, someone's using Linux, someone's using Mac. We will be supporting Mac OS and Linux. Now, if you have a Windows 7 machine, kind of would prefer you use that because Visual C++ is the IDE I'm most familiar with. However, we do have, I can pull up a Ubuntu machine and a Mac OS machine at any time to go over Xcode or Eclipse CDT or KDevelop 4. Those are the IDEs that we're going to be supporting. So yeah, looks like there's one person using Linux, a few using Mac.
Okay.
So yeah. So were you going to go over the class certificates or homework, or just
Actually, jumping right in, I'm gonna wait for the regular type of class stuff like that until next week when we settle down with our real class, basically, with our real students.
Alrighty. So I guess one of the most important things that people should know, and it would be interesting, how many people are completely new to programming? No, Gavin, I know you're not.
Just feels like it.
All right, sweet. So when learning a programming language, knowing what to expect is very important, because what we're going to be doing in this course in particular is going over the syntax of the C++ language, and we will also be going over, hopefully, the people going through this course will develop a way to sort of think of problems in a very procedural and logical way, because that's going to be the most important thing to develop as you start to program, because you have these languages that allow you to express logic, but you also have to think of or come up with the logic to express to reach a certain goal. Now, we will be spending the entire time of this course in the console window. And what I mean by that is the little black and white text box thingy that you get right here. Now, the reason we're doing this is because this is the best and simplest environment to go over the logic of programming. So we're not going to be jumping into writing UIs or games or anything like that, but I want to stress how important it is to learn the syntax and the fundamentals of a language before jumping into using something like a game engine or a graphics library. So I really want to managing expectations is really important. So I want to just say it up front that we will be spending the time in the console window, but this is very, very, very important for any beginner in programming.
That's right.
All right. So C++ or different programming languages in general. Like I said before, a programming language is just a way, it's a dialect of a way to express logic. Just like how the English language is a way to express a variety of different things, programming languages are about expressing logic, and there are a variety of different programming languages available. All the other different programming language, every programming language has a bunch of characteristics about it that make it particularly suitable for certain goals. Now, C++ is an interesting language because it was born out of a language called C, which is a very low-level, bare metal sort of language that allows you to interact very closely with the computer you're working on. C++ is an interesting language because it is that same level of closeness to the hardware, but coupled with a variety of what are called high-level language features that allow you to express things in a really nice object-oriented way. Now, a lot of people here, I assume, are at least familiar with the existence of Java and C#, and it might be interesting to kind of go about, kind of talk about the differences between C++, Java, and C#, because, again, Java and C# are fairly popular languages that I'm sure a variety of people here know about. Java and C# are managed languages. What that means is they don't work so closely to the machine as C++ does. On the flip side, they have a lot more advanced high-level features that allow you to be more, or can allow you to be more productive at the trade-off of some performance and ability to interact with the computer. Now, C++ is a great language to learn, though, because throughout this course, especially once we start getting into the 102 and 103 classes, people are going to get a very, very good feel for how code executes on their computer. And I want to point out that no matter if you're using a managed language or a native language meaning C or C++, the way that your programming language ultimately interacts with the computer is the same. So I think C++ is a great language to learn for people who really want to get a feel for how code executes on your computer. We're not going to be spending too much time or any time at all really on things like assembly or anything else in this 101 course, but that sort of low-levelness, that sort of memory management and bare metal programming is definitely going to be gone through in later courses. So yeah, I just wanted to point out that C++ is a low-level native language that is similar to the expressiveness of Java or C#, not as much, but similar, and it is suitable for a variety of very high-performance applications as well as a great learning environment.
Now, Nelson, there's a couple of questions that have come in over in the webinar panel that I think would be good to have answered right now. We had one question with it being, what's syntax?
Syntax is what's the language? Like I said before, a programming language is a way to express logic. And the way that you express logic inside of a language is its syntax. So a syntax are the words or characters that you will be typing into a text file so that that text file can be converted into a working program. See, that's the goal of a programming language, is you type in text and then you get somehow, through a variety of different means depending on the language, a working result. So a syntax of a language is the structure of it, is the characters and symbols and rules that you have to follow in order for that programming language to be successfully executed in a given environment.
Okay, another question came in with low level, high level.
Low level is the closest you get to the CPU or the closest you get to the processor that your code is executing on is considered to be low level. So low level is very bare metal. It means that you will not have a variety of language features or runtime features that can increase productivity, but you have a lot of control over what exactly is happening on your computer. So you have complete control over memory allocations, deallocations. You could have as much control in the C++ language as setting registers, which is ridiculously low level. But the idea of a low-level language is that it's very bare metal. It's very close to the operating system that you're running on top of, or very close to the CPU that you're running on top of. A high-level language, on the other hand, will oftentimes, or a more high-level language, will oftentimes have what's called a runtime. A runtime is a little piece of software that runs parallel to your program and kind of manages it, kind of does things for you, cleans up after you, informs you of problems, prevents bugs in your software, gives you some more flexibility in regards to being able to write against the same runtime in a multitude of languages like .NET. And both C# and Java are very high-level languages because they have this runtime, this little program that kind of sits between your executing code and the CPU itself. And it's always going to be a trade-off of productivity versus performance. Although that isn't necessarily true. I'm not going. C# and Java are not slow languages. Now, Java used to be a very slow language, but they've gotten a lot better in recent years. And there are situations where C++ and C# or C++ and Java will run at very similar speeds. That being said, you can write poor, unperforming code in any language or runtime, which is why I suggest learning C++ so much, is because all the stuff that things like the .NET framework and the Java runtime, and even dynamic languages, the Ruby runtime or Python runtime, all those awesome features that boost your productivity, you need to understand what they're doing behind the scenes in order to write performant code. And learning C++ will give you that perspective.
We also had one other question that came in, which is the console window the same as the terminal on my Mac?
Nope. Well, similar, but no. We will be using it in a similar fashion, but the terminal on your Mac is going to be using a shell, that bash, I believe, is what Mac uses. And I'm not 100% sure on that, by the way. And the terminal in any Unix environment, so that's Mac or Linux, is going to be significantly more powerful than the console window inside of Windows. But we're going to be using it in the same fashion. So if I bring up my Mac, for example, let me fire up my terminal first. I don't know what's going to pop up on it. Where are you? Here you are. Okay, so here's my terminal on my Mac. And it's going to be a very similar, we're going to be using it in a very similar fashion. But again, the terminal on a Mac is going to be significantly more powerful than the console window in Windows.
One other thing, I don't know if you saw what Gavin and
yeah, if you just move your rotate your mic up or down about an inch, Nelson, there's lots of sibilants and plosives.
I don't know what a sibilance means.
Every time you hit an S or a P, there's it over.
Okay.
Yeah, just move it out of the line of attack.
I'm sorry about that. Okay, so we have I see some questions going in the class IRC. I really want to answer those, but please put them in the webinar because that chat scrolls very quickly and I can't keep an eye on that window. So especially because there are some questions I did want to answer from $6 Man and Surreal and a few others I can't even find again. So please post those answers in the webinar questions panel. Okay, so all right.
So there you go.
Oh, don't apologize for being completely new. That's actually the target for this course. So
absolutely. And there, Donald just had a question for you over on the questions panel that came in.
Yeah, is learning C++ and C# at the same time incredibly difficult? That's going to be really dependent on you. There's no way that I can really answer that definitively, but it is entirely possible. C++ and C# share a variety of syntax. Obviously, they're both C-style languages. And so they're going to share a variety of syntax, but I wouldn't say it's impossible. I would say, try it. Try learning C++ and C# at the same time and see what happens and see what you're more comfortable with. If you find that switching between the two languages is too difficult, you can always choose one and go back to the other one later. As far as which one to choose, that's, again, entirely up to you. It depends on what you're trying to get out of programming. Can you expand on the levels of CPU interaction, i.e. low level equals binary? All instructions that are sent to the CPU, all commands that are sent to the CPU are well, they're just machine codes, really, which are just numbers. And numbers can be expressed in binary or decimal or hexadecimal or whatever. But as far as low-levelness is about the closeness to the CPU that you have. .NET is very because all the .NET languages are JITted or just-in-time compiled. There's kind of a buffer layer between the code that you write and the code that gets executed on your CPU. Languages like Python or PHP or Ruby, which are interpreted, there's even a higher buffer between the CPU and the language you're writing. And explaining exactly what that buffer is kind of difficult without any context of programming. But that's the best word I can think of right now is the word buffer. There's a thing that sits in between your C# code and the code that runs on your CPU, just as there is between Python and the code that runs based off your Python programs, but there isn't that buffer in C++. C++ turns directly into machine code instructions that gets executed directly on your CPU. Is there any coding program like Notepad++ that you'd recommend? I would highly recommend anybody using Windows to jump over and grab the Visual C++ 2000 Express. Now, I want to point out, though, that Notepad++ is a text editor. It does not include what's called a compiler. And in order to translate the C++ code that you're going to be writing into a program that can execute on your computer, you need a compiler. And if you just were to download C++ or Notepad++, you would get syntax highlighting and other text editor features, but you wouldn't get the actual program that takes your C++ code and turns it into a working program. If you want that program, that compiler, grab the Microsoft Visual C++ 2010 Express, because this is going to include a text editor as well as a compiler that you can use. Does C++ have event handlers like ActionScript 3.0, or is it structured more like JavaScript? Well, it doesn't have any built-in concept of event handlers, but I can say this, it's nothing. Well, it's not nothing like ActionScript or JavaScript, which are both based off the same standard. It's just ActionScript has some extensions to it, I suppose. But JavaScript in particular is very, very, very bizarre language, and it's a very, very high-level language that is not going to behave anything like C++. Some of the features will look similar, but it won't behave like it would. And there are no event handlers built in to the language itself, but there are ways to express an event handler logic with C++. It's just it doesn't have a built-in language feature for that.
Now, Nelson, you went over how to go about getting your IDE for Windows. Let's talk about Mac and the Linux operating systems real quick.
Okay, so if my stupid TeamViewer window is gonna, there we go. Okay, how do? Alrighty, so for macOS, the IDE that you're going to want to be using is going to be Xcode. So if you're using Lion, or you have, I don't know if the App Store is available on Snow Leopard, go ahead and jump over to the search bar, type in Xcode, and hit enter. You're going to want to grab this program. This program is going to include a compiler and an IDE for C, C++, Objective-C, and I don't know what else. I don't really use Xcode. But this is the IDE that we will be supporting in this class for macOS. For Linux, now for Linux, it's going to be a little bit difficult because not all distros are the same or have the same package manager. But if you are using Debian or Ubuntu and you have access to Aptitude, simply install the package Eclipse, I believe it's Eclipse-CDT. So you can install this either from the terminal or from your solution or package manager GUI, which I don't know how to use, or grab kdevelop or just kdevelop. Kdevelop will include the KDE window manager, but it will not be required to use. You can use kdevelop inside of GNOME, which is the default for Ubuntu. So Eclipse CDT or kdevelop if you're using Aptitude. If you do not have Aptitude or your package manager does not include either of those, all you really have to do to grab CDT is head over to eclipse.org and download Eclipse and grab the Eclipse IDE for C and C++ developers. Now, if you install this manually, you will have to also install what's called GCC, which is the compiler that you're going to be using on Linux. So just grab CDT or kdevelop. Again, it'll be way easier if you have a package manager that supports it. But if you don't, you can just grab this and extract it somewhere and run it. It's just a Java program.
And we did see the question, is it free? All of the different IDEs that we're going to be using are free.
Yep. So somebody asked, what are we going to be typing code into on the Mac? That's going to be Xcode. And when we start a new project here shortly, I'm going to start a new project on all the IDEs that we support. Alrighty, so
just a couple more questions over there, and then we'll go ahead and get going again, because otherwise, with the class being as large as it is, when we do these free classes, we could literally spend the 2 hours trying to handle questions that continuously roll in. But there were a couple other good ones that were put over into the questions panel, Nelson.
C is still used quite often, even with the uprising of C++ in recent times. What are the advantages or disadvantages of using one over the other for various applications, drivers, OS development, and programs? It really depends on what you're doing. If you're doing embedded development, and when I say embedded development, I mean the kinds of programs that run, I don't know, dishwashers and ovens and watches and other embedded devices that aren't PCs. You would generally be using C because on a lot of those architectures, C is the only available language that you can compile for, with the exception of assembly, of course. So you'll be using C in that case quite a bit. For driver development, you'll generally also be using C, simply because they're in that sort of development, you will not necessarily want to use the features that C++ gives you, and you'll want to maintain compatibility as much as you can with other DLLs and other things that are difficult to do in C++ because of name mangling and all that stuff. So you'll generally be using C for very low-level things. For applications and games, there is no reason to use C. Just jump with C++. There is a C++ compiler available on every major app or every major platform and every major architecture.
But when would you specifically choose C++ over C#?
I wouldn't. I might for
Into the P.
I would, if I was, let's say I was writing a high-performance concurrent web server, I would use C++. But then I would expose the API in such a way that I could write application logic in C#. If I was writing a extremely high-performant game engine, I would go with C++ and again expose the API to Mono or to the Microsoft CLR and use C# for the application logic. So as far as when I would actually use C++, that is a different question to should I learn C++? And I am very glad that I learned C++ when I did, even though the majority of my time I spend in managed or dynamic languages. Are we going to learn the new C++ standard, or is it just regular C++ that explained in the old books, if you catch my drift? We are going to be going over a few features of the C++ 11 standard. Now, remember that the C++ 11 standard is backwards compatible with the old C++, what was it, C++ 03, I think is what they called it. And it's backwards compatible with that. And not only that, the C++ 11 spec really just adds a few language features and a few standard libraries. And the language features and standard libraries introduced in C++ 11 a lot of them are out of the scope of a one-on-one course. We will be using features of the C++ 11 specification, and we'll be using the ones that make the most sense in the context of what we're teaching. Can you... Can you give me examples of when C++ applications would be used? Well, I hopefully already answered that.
Yeah, I think you did.
Is my source code cross-platform? We're going to be working, we're going to be trying as hard as we can to write cross-platform code that compiles between the IDEs that we support, or the compilers that we support. When I was in college, there was talk about game programming switching to C# because of DirectX 10. Is that still true? game programming switching to C#. I mean, the language and platform that a particular development team uses is up to them. I suppose you could say the industry standard is C++ for game development, or at least game engine development. But in modern years, we've seen a lot of managed environments being used for the game logic. Like, for example, Unity, which uses Mono, which is a .NET platform that allows you to write in a variety of different languages, including C# for game logic, even though Unity itself is written in C++. All right, so...
Okay, so let's go ahead now, Nelson, and jump into writing our first C++ program. Because like I said, if we sit over in the questions panel, we'll literally be there all day.
All right, so let me go ahead and find my Windows 7 VM. All right, so I'm going to go ahead and launch Visual C++ 2010 Express.
Now, while Nelson is getting this up, again, a quick reminder, this is a class structured for complete beginners. And in BuzzNet, we have a means of having everyone let us know if they're participating with us and if they need another minute, if they're following along, or if they have finished what we've asked them to type out. But we're not going to be using BuzzNet since the first two classes this week are free. What I would like for everyone to do, though, is to look over in your webinar software, and there's an area where you can raise your hand. See if you can find that. This is what we've been doing for the free classes. Everybody find that and click raise your hand. Hey, look at all the hands light up. Now we get to see who the slow people are.
I need a bigger monitor.
All right. Most hands are now up. So when we would like for you guys to follow along with us, we're going to have you raise your hands to let us know that you are engaged with following along. And as soon as you've completed whatever it is that Nelson is asking you to type out, put your hand down. So now let's everybody try putting our hands down. Faster, 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 faster. Anthony, there you go. Sweet. Okay. Nice one, Barry. I saw that. Okay, good job, guys. So now everyone has been trained on how we will track your progress when following along. Nelson, let me hand it back over to you, sir.
Yeah, I do want to point out two things in the chat really quickly. Somebody asked, Visual Studio 2010 Express doesn't support all the C++ 11, only Visual Studio 2011 Express supports it. Is that true, or both support, blah, blah, blah. Visual Studio C++ or Visual Studio 2010 supports the features of C++ 11 that we will be using in this course. So I wanted to point that out. And Segfault says, saying things like C++ is the best for games is a dangerous statement, and that's true. So let's go ahead and open up Visual Studio. Visual Studio, if you have Visual Studio. If you are on the Mac, we will be going over Xcode after this. So, all right, so go ahead and hit New Project, and you're going to want to go ahead and select the Win32 console application. Now, if you are using Visual Studio Professional or Ultimate or whatever, you might have to jump around in your installed templates on the left here and locate the Visual C++ tab. Now, you're going to want to click on the Win32 console application. That's important. You do not want anything else other than the Win32 console application. So after that, go ahead and enter a name. So any name is fine. I'm going to call this Project 2. And I'm simply going to place it in my Visual Studio 2011 projects directory.
Okay, let me see a show of hands over in the webinar. How many people are actually trying to quickly install an IDE right now? So put your hand up over there if you are trying to install an IDE. All right. So there are actually more people than I realized that do not have an IDE already set up on their computer. So here's what we're going to do. We're going to go ahead and take a break, and I will pause recording. Now let me remind those of you that have never attended any of our classes before, if you need to leave because time is an issue, don't worry. I will be making this recording freely available to everyone on 3D Buzz, if not later this evening, then tomorrow. So let's go ahead and pause for a second. Okay, we are now resumed with the recording, and Nelson, let's continue.
Alrighty, so now that you have, hopefully, Visual Studio and again, we'll be going over the other IDEs very shortly here. Visual Studio 2011 Express, or 2010 Express. Go ahead and jump over to the new project and select the Win32 console application underneath the Visual Studio or Visual C++ templates. Now, we did have a question as to why we're choosing the Win32 console application instead of the others. I want to point out that we are not going over C++ CLI, which is what these CLR projects are for. We are not going over Win32 applications, which is what this is for. And this is another CLR application. We're not going to be covering makefiles. We don't want an empty project because we want some settings set for us automatically. And we don't, yeah, so that's pretty much it. So go ahead and select the Win32 console application, type in a name. I'm going to choose project 2. And I'm going to hit OK. And what you'll get is this little application wizard that is very annoying and has existed since the dawn of Visual C++, and I hate it, it's gross. But what you're going to want to get in the habit of doing is jumping over to the Application Settings tab over here on the left. So you see there's Overview and Application Settings. Make sure that Console Application is checked, and make sure that you select Empty Project. Now, the reason we want to select Empty Project is if we don't, Visual Studio will give us this project template that has a bunch of things that we are not going to be covering, such as precompiled headers and, well, header files in general. So we want to select Empty Project to get nothing. So we want to start with nothing. So go ahead and hit Finish, and what you'll get is this. Actually, that's kind of a lie. If you just installed Visual C++ Express, what you'll get is this. However, I prefer my Solution Explorer to be on the right of the screen. And for some reason, the C++ Express has it on the left, and I find that annoying. So I like moving my Solution Explorer to the right side to make it consistent with the other languages or the other IDEs. So you'll have these 3 folders: header files, resource files, and source files. Now, these are not real folders that exist in your file system. I want to point that out really quickly. If I was to open this up in Explorer, which I can't because whatever, I can actually over here, I guess. You will see that there is no such thing as a headers file or header files or resource files or source files. These are virtual folders. They don't actually exist on the file system. I do want to go ahead and just show the process of right-clicking on the source files, because this is the folder we are going to be worried about at the moment. Right-clicking, going to Add, and going to New Item. Once you're in New Item, select C++ file with the file extension of CPP and enter a name. The name we will be using for this file is going to be called main, and then hit Enter. Now you'll get a text editor where you can type in code. So because every single IDE has a different process of actually starting a project, should I just type in an empty main?
I would at this point let those that are following along finish getting their new project set up, but I would go ahead and hop over to the Mac, get Xcode up, and go ahead and again get to the exact same place, and then do the same over in Ubuntu.
Okay, so let me bring my Mac over. All right, so go ahead and jump into Xcode. So find Xcode and click on it. And of course, there's a project already open. So I'm going to go ahead and close that project. And when you open up Xcode for the first time, you should get this. I think I can get back to it by hitting this key. There we go. So you should have this screen if you opened up Xcode for the first time. Now, what you're going to want to do is select Create a New Xcode Project. That's going to bring up this window. And you'll see that we have iOS and Mac OS X. We're going to want to select under Mac OS X Application, and we're going to want to select Command Line Tool. So this is going to be your equivalent console application. Hit Next. Type in a product name. So I'm going to call this Project 1. Type in a company identifier. The easiest way to do that is just type in your initials. In this case, I did, NJL. Now select C++ of the type. We're writing in C++. Do not check Use Automatic Reference Counting, and hit Next. Finally, find a location within your hard drive using this Finder window to locate your project, and I'm going to stick it right here. Now, I'm not going to create a local Git repository for this project, so I'm going to uncheck the source control. I'm just going to hit Create. So now what we have is this window, and to get to the same code file that we will be editing, click on main.cpp. Now you'll see that it inserted some code for us, but what you're going to want to do is go ahead and select all of this and hit delete, and then save. So just so we're starting from the same point from on both of our environments. So now I'm going to, so is that good for Mac OS?
Mm-hmm.
Now I'm going to move over into Ubuntu. Now with Ubuntu, we will be covering two IDEs that both use the same compiler, GCC. So the first IDE that I'm going to take a look at is Eclipse. So I'm going to go ahead and run Eclipse.
Nelson, I would say, I mean, both are free. I would just stick with Eclipse only. I mean, we put in the syllabus that they're welcome to grab either of the two, but let's just focus on one. So it's only one per platform. I would just keep things from getting too muddied up.
Alrighty. Should I have a main.h file? No. Hopefully not. If you do, you might not have selected empty project in Visual Studio, because I'm assuming you are on Windows, right? So you might want to nuke that project and start again. Okay, so go ahead and fire up Eclipse. Now, Eclipse, I actually do have a lot of experience working in Eclipse for PHP. It has a concept of what are called workspaces, and a workspace is where all your projects are going to be contained under. So as far as selecting a workspace, I'm just going to select root home Nelson workspace, and I'm going to hit OK, and that's where it's going to place on my hard drive all of the projects that I create. Now, the first time running CDT, you won't actually see this. You will see well, you see something, and it doesn't matter because it won't look like this initially the first time you run CDT. But if you go to File, New, C++ Project. Now, if you do not see this, if you installed CDT as an additional plugin, you might not see this. Eclipse is a very versatile platform that has plugins for a variety of different languages and platforms. And they have different packages that you can come with. If you started with like the Java package and added C++ support to it, you might not see this option. So if you do not see this option, go down to Other. Go down to the C and C++ folder. This will only appear if you have the CDT tools installed. Expand that and select C++ Project. Hit Next. Now you'll be prompted for a project name. So I'm going to call this Project 1. And you'll see that the location it uses is root home Nelson workspace Project 1. So it automatically placed under my workspace. I can change that behavior if I wanted to, in which case I would have to manually specify a directory for my project. But I'm just going to go ahead and click on that. Now you want to, on the project type, we're going to want to select empty project. Now for the tool chain that we want, in this platform, we will want the Linux GCC. So if I uncheck this show all project types, you see that I can build for Solaris or Windows or Mac OS or Linux GCC or SageWin. But in this case, we'll want the Linux GCC so that our built executables can run on the same platform we're working with. So go ahead and hit finish. And over here on your project explorer, you'll see a nice little project one. This project, oh, by the way, when you created that project, you might have gotten a window asking you to change the perspective to the C and C++ perspective. Now, perspective in Eclipse is basically a layout for your windows and toolbars. There's a variety of different perspectives supported, but in this case, we're going to want to select the C and C++ one. So if you get that dialog, say yes. If you already clicked no, go down to this open perspective dialog box and select other, and then select C and C++. And that'll give you a window layout that is very similar to what you see here. You might have to close the welcome window as well. So I just close that. I can't remember what happens when you first run a thingy. So over here on project one, right click, select new, and select file. Now for the file name, just to be consistent, we will be using main. You don't want anything more advanced than this, just main. You don't need any of these settings. Now if you hit finish, what you'll get is a place to type in code. So at this point, if everybody followed along, we should have a file open. Actually, scratch that. I'm going to delete this file because it should be not this. It should actually be main.cpp. So my bad. So do main.cpp and we'll get this nice little window. So at this point, every single IDE, so that's Eclipse CDT, Xcode, which let me drag over Xcode. Should have an empty file main.cpp, you'll see right there. And Windows should have a main.cpp, and they should all be blank.
Now, Wolf's having some issues if you check the questions panel.
So in Windows, yeah, I can go ahead and I'm going to go ahead and we'll close out this project. No, I don't want to save anything. If you fire up Visual Studio from scratch, go ahead and select New Project, Win32 Console Application, give it a name. In this case, I'm using Project 3. So remember, you must select the Win32 Console Application, or some of the settings in your project might not be what you need to follow along with. Select OK, go to Application Settings, select Empty Project. So remember, in this wizard, you want to go to Application Settings and select Empty Project and hit Finish. Once you hit Finish, you'll have this empty solution. And to add in the main.cpp, we can right-click on the source files folder, go to Add New Item, select C++ file, and type in main. And hit Enter, and we'll have a main.cpp file. Unreal, yes, actually. That is something we're going to do once we get everybody up to speed. Shouldn't file names be lowercase? If you want them to. I don't like lowercase file names, though. I see that is very common between C++ applications, but just the way that I see things, I prefer uppercase file names.
Controversial.
It might actually be for most C++ applications I've read through use lowercase. But I'm using uppercase and I'm the instructor, so haha. Okay, is everybody in their IDE at the location that we are at this point? So are we all in main.cpp now? Raise your hand if you're not in main.cpp. All right, Wolf, what does your environment look like right now? Like, are you? I'm assuming you're using Visual C++ right now. Okay, were you able to create a new project, an entirely empty project? Okay, well, if you're not using Express, let me fire up my host Visual Studio. Eventually. Visual Studio is one of the most performant applications I've ever used in my life. Okay, so if you're in Professional or Ultimate, go over to New Project. You're going to want to go to Other Languages if you did not select C++ as your primary language. Jump down into Visual C++, jump down into Win32, select Win32 console application, give it a name. Hit OK. Make sure Add to Source Control is not checked, and make sure Create Directory for Solution is checked. Now hit OK, and it's going to be the same process. So you go down to Application Settings, select Empty Project. Oh, okay. Well, in that case, so I'm going to go ahead and just finish this. The reason it's making a .h instead of a .cpp, and that's very important. If it was a .h, things will not work right. Go to source files, hit add new item. Make sure that you selected C++ file with the extension of .cpp, not header file. There's a very, very important difference between these two things. So select C++ file. And once you select C++ file, go ahead and type in the proper name. All right, sweet. Alrighty. All right, so we still have two people with their hands raised. What problems are you guys encountering with starting up a new project?
And while we're waiting for any feedback from them, if you take a look over at the questions panel.
Are we going to be learning about header files in this course? Header files are very interesting, and we are going to be going over them in week 4. But I want to point out that that they have a very different behavior than CPP files as far as compilation is concerned. So for right now, we're just sticking with main.cpp, one CPP file. Once we start talking about multiple CPP files and using headers to share code between them, things get a lot more complicated.
And a quick note for all the people tapping /join #class into the webinar questions panel, you need to be typing that into your chat client.
I don't have a chat window on mine. It's going to be under, if you go to 3dbuzz.com and you go down to chat, you'll be able to open up a chat window in your browser. And then that's where you type in join class.
After you hit connect.
Yep. So you hit connect, and then once you connect into this, then you type in join #class and hit enter, and you'll be placed into the class chat. Okay, so JM and Gamester, what? I mean, are you guys still having issues? Because project creation failed in Visual Studio. I'm not sure if I understand project creation. Like, did it give you an error of some sort? I mean, we can switch over to your screen and check out what problems you're having there. if you want us to. Okay, never mind. I lost some. What's this?
By the way, when you type a question into the questions panel in webinar, only Jason, Nelson, and myself can see it, not everyone.
Yeah. Okay, so JM, we're going to switch over to your screen and check out the issue that you're having. Okay, so if you, go ahead and give it a name. And then go to View, other windows.
I think he called it Project 1. If you've created a Project 1 before, would that be causing that to happen?
Maybe. I don't know why there's no output window for him right now, but anyway. So yeah, try another project name. Huh. Yeah, that's not gonna. Let's do
this so that we can go ahead and move forward. Just hang tight. When we get over to a break, Nelson, then let's jump back over to his screen and see if we can spend a minute with it.
Alrighty.
Okay.
Yeah, try restarting your computer also. Because I just don't know. I haven't seen that before. All right, so I guess I'm going to jump over to me. Where am I? There I am. Okay, it looks like there's some troubleshooting in the chat if you look over there. So just check over on the IRC. Okay, so what about Gamester and Terry? Are you guys having the same problem? If you guys still don't have this project open, I mean, could you post a question, or in that, if you don't, we'll just move on. Okay, well, I'm not seeing anything from either of them.
So yeah, let's go ahead and go.
Alrighty, so inside of your IDE, inside of your main.cpp, I'm going to be writing out some code. And you probably won't understand the code that I'm writing out, but we will be going over every bit of syntax that I'm going to be typing. So start off with a pound symbol, followed by the include keyword. Open up an angle bracket and type in IOStream. After that, type in int, the keyword int, and you know it's a keyword because it's colored blue, space main. Now this must be lowercase and it must be int, followed by an open parenthesis and a close parenthesis. Enter a new line, open up a curly, and then close a curly. And when I say curly, I'm talking about the result of holding down shift and opening up an angle bracket. So as far as the symbols that I will be using, I will refer to these as curlies, or curly braces, these as parens or parentheses, these as angle brackets, and then these as square brackets, and this as a semi or a semicolon. Okay, so now that we've opened up main with our sideways mustaches, go ahead and type out the words std, followed by 2 colons, and then a really funny, a funky looking word. And the way that you pronounce this is called C out. So you see C followed by the word out. So when I say C out, I'm referring to this. It's kind of a funky word to pronounce. Now hit space after std C out and type in 2 of these opening angle brackets, followed by a double quote, followed by the string literal hello world, and an end double quote. At the end of this, insert a semi, followed by 2 new lines, the keyword return, followed by the numeric constant 0, followed again by a semi.
And in a minute, Nelson, you might want to walk people through how to turn on line numbers.
Yeah, I'm going to be doing another tour throughout all these IDEs in a second to show people how to launch it, and I'll add in line numbers to that.
Okay, great.
Somebody asked, why is my line yellow instead of green? The reason is I have a habit of hitting Control S after every line. A yellow line indicates that you have changed that line since you last opened the file. By hitting Control S or going to File Save, it'll turn to green.
And just as a general thing, at this point, if there's things you don't understand, or if there's things that are, or you do understand that Nelson isn't doing yet, can we try to keep things to, don't be asking questions about things that are way out of scope of lesson 1 of a beginner course?
Right, and all these language constructs we're using now, we will explain. So, I mean, at this point, if you asked what include meant, I would just say we're going to be covering that in a second once we tour through all the IDEs. I do actually want people to type in one more line after the std C out, and that's going to be std : cin dot get semi. So that's std cin.get semi.
Is that like a read key?
Yeah. Okay. Alrighty. So this is the program that we have written. And to run this program, you have a few options. Either hit F5 or this Start Debugging button up here. So if I were to hit F5, you'll notice that Visual C++ 2010 Express tells me this project is out of date. Would you like to build it? Well, yes, I would. I'm going to check the box Do Not Show This Dialog again, because this dialog really annoys me. After checking Do Not Show This Dialog again, I'm going to hit the Yes button, and you'll see that a build started. And then a console window opened saying Hello World, and execution is paused. And now if I hit Enter, execution terminates. Now, this process right here of building is very important. What's happening is this code file is being sent to a special program called the C++ compiler that takes your code file, it takes your text, it understands the syntax of the language we're working with, and produces a runnable program. Alrighty, so yes, Quest is right, but I still prefer to run in the debugger as much as possible. So yeah. Alrighty, so this is Visual Studio. Now, I do want to point out, I'm going to be talking, Ethan asked, what's the difference between using cin.get and system pause? There's a big difference. Actually, I wrote up something on Stack Overflow about this difference once, and it's just very important. I'm not going to be going over the specifics. If you want to find out, just Google it on Stack Overflow. You'll find me somewhere. This is basically bad and horrible, ugly, not cross-platform, horrible performance, very insecure and terrible all around. So instead, we will be using cin.get. Okay, so this program should be working in Xcode, but I'm going to be covering Xcode in a second here. Now, to make things a lot easier for people to point out, and just in general, I prefer line numbers to be on. So what you're going to want to do, if you're in Visual Studio, I'm going to go over how to do this in the other IDEs in a moment. Go ahead, jump to Tools, head over to Options, open up the text editor, open up All Languages, and click on General. Then say under Display, you want to check line numbers. So does anybody need me to repeat that? That's going to be under Tools, Options, Text Editor, All Languages, General. So again, Tools, Options, Text Editor, All Languages, General. And under Display, check line numbers. So after hitting OK, we get some nice line numbers. Alrighty, so let me jump over to the other IDEs really quickly. Bring up my Mac, and I'm going to go ahead and type in the same program. Oh, come on. This is going to be a bit painful because I'm using TeamViewer on a Windows keyboard. So just bear with me. No, I didn't want that to happen. Oh, stop. Okay, let me go ahead and try to expand my text size on this. I'm not sure if I can. Yeah, I don't know. So, alrighty. The line number settings will remain no matter what you use. Okay, so to run this program in Xcode, go ahead and hit the Run button, and you'll get the same thing. You'll get a building project, a build succeeded, and then down here, you'll get your console output. So if I were to hit Enter, you'll see that the program terminates with code 0, which, hey, there's a 0 there and a 0 there. I wonder what that means. Anyway, so the point is that inside of Xcode, you'll get your output down here on this All Output window by hitting the Run button. Not entirely sure what the keyboard shortcut for Run is, but if you know it, then you can use it, I guess. As far as turning on line numbers, I'm going to take everybody on an adventure as I figure that out inside of Xcode.
Show us a magic trick, Nelson.
Yeah. It's pretty much going to be a magic trick. Is that under Edit? Is that under File? Is under Xcode?
And go to Preferences.
Preferences. Okay, we're probably getting warmer. Oh, this is scary.
Text editing.
Text editing. Oh, there we go. Under Xcode, Preferences, Text editing, there's a line numbers button. So go ahead and check that. Close out of this dialog, and we get nice little line numbers here. And go away breakpoint. Does anybody have any questions about Xcode? Since I don't know Pascal, so I wouldn't be able to answer that. Core says build failed. Are you in Xcode? Let me go ahead and see what the error window looks like. Introduce a syntax error. Okay, click on, do you have any red lines on the left, Core? Like, are any of these lines highlighted red? This is a compiler error. A linker error would be different. I hope he's not getting a linker error. That would mean his standard libraries aren't being used. Bob Rick, I'm just using that as an example to see, to remind myself how errors show up in Xcode. Do you get any messages at all, Core? Command failed with Xcode 1. Are there any other messages that might be being presented to you in some way? Duplicate symbol main. You only do have one main.cpp file on your project 1, correct? And inside of main.cpp, you only have one main definition? He might have created a seed project, actually, because duplicate symbol underscore main would be weird because C++ mangles the names more. So yeah, when you start a new project, if you go to File, New, New Project, make sure that you select Command Line Tool, and also make sure that you select Type of C++. Okay, just let me know. STD C++? Sure. That should work. Okay, so just let me know how that goes. I'm going to jump over into Linux now for those people. Okay, so for Linux, inside the main.cpp file, simply type in the same code we had before. Include iostream, int main, paren, curly, curly. Well, it auto-inserted a curly down there. std, cout, hello world, std, cin.get, return 0 semi. The Eclipse IDE does use G++ slash G, well, the G++, which G++ is the GCC C++ compiler. It does use that in the background. You might be able to configure Eclipse to use Visual Studio, or Visual C++, I'm not sure. As far as the difference between cin.get and system pause, there are a lot of differences, and system pause is horrible in every possible way imaginable. If you want to know what those differences are, just Google it, because there's a variety of documentation explaining how terrible system.pause is. Okay. So, yeah, so now inside of this new project, you're going to want to hit run. Well, first of all, if you hit run, you'll get a launch failed binary not found. With Eclipse, you have to create what are called build configurations. Now, fortunately, doing that is very simple. Click on this little arrow right here on this run icon. Go down to run configurations and open this up. Now, with run configuration selected, you'll want to double click on C and C++ application, and you'll get a new build configuration. Now, if it says program not specified, you'll want to select your project 1 using this. So under C++ C application, you'll want to search project, and we don't have any binaries yet. because we didn't build for some reason. Why didn't you build? There we go. What I did is I went down to project and I said build all, or Control B. So now if you jump back into your, now if you jump back into your run configurations, you'll be able to select the C++ C application right here. You'll see under binaries, there's project 1. Hit OK. And now that you have that selected, you're good to go. So now you can say apply. And this setting is something you only have to do once per project. Now go ahead and hit run, and you'll see down here that the output comes in this little console window. And if we hit enter, the program terminates. Another important feature of this console window is how to terminate the process prematurely, and you do that with this little terminate button right here. Now, if you prefer to run this in your favorite terminal, you can. So if you open up a terminal, find your project, which I believe is going to be under Workspace, Project 1, Debug. You'll see that there's a Project 1 executable we can run. So we can say Project 1 and hit enter, and we get our program running inside of a terminal. So that's cool. stdnl is not appropriate right here. There's no reason why we should use it. The behavior of stdnl is simply to go to the next line of code or in your terminal. Now, does anybody else have any questions? Do I use virtual machines to show us Windows, Mac, and Linux at the same time? I have 2 VMs, one with Ubuntu and one with Windows 7. And then I have a TeamViewer instance that's team viewed into my MacBook upstairs. So this is a physical computer. These 2 machines are virtual, the Windows and the Ubuntu. Yes, we'll talk about cin.get and std. I was just, the kind of questions I'm looking for right now are the questions involving getting this simple code executing and running on your operating system, not necessarily what the code itself means, because we're going to be stepping through this line by line by line. Oh, I did forget how to do that. To show line numbers in Eclipse, very, very easy. Jump over here. Actually, I believe, they must have changed that shortcut. That's kind of sad. There used to be a cool little shortcut that, oh, there we go. If you hit Control-3, you'll get this cool little search bar that'll actually search every single option inside the IDE. And if you type in line numbers, you can simply select show line numbers. So that's Control-3, type in line numbers, and we can toggle on and off that option. If you don't like awesome keyboard shortcuts, you can go down to Window, Preferences, General, Editors, Text Editors, and Show Line Numbers, and you can toggle that option on and off. Indentation is incredibly important. Please follow the indentation scheme right here. You're welcome to follow this indentation scheme if you are already familiar with it, but I would advise that just in general, this indentation scheme is followed. Whenever you see an open curly, every line after that should be indented. Whenever you see a closed curly, that line should be unindented. VC 2010 should have auto indentation, but in that if you continue to hit enter, it'll automatically indent your line. But I don't believe it has any code formatting tools with it. Alrighty. Do I really need line 6? For Windows, I do. For Ubuntu and macOS, I don't. But I'll be covering what that does in a moment here. Alrighty. So any more questions about getting this to compile? Because I'm about to go ahead and explain this program line by line. I just want to make sure everybody's comfortable in the environment that they're in. They have this code written and they can run it. Everybody good? Raise your hand if you have any questions, and then I'll wait for you to type it out. Otherwise, we will continue in about now. Alrighty. So what we have right here is a program. And all the program does, or all the program is it's a text file called main.cpp that contains code. And code in any programming language is simply text that follows the syntax and the semantics or the meaning behind a particular way to express logic to a computer. So in C++ or in any language, you have a variety of rules that you must follow. And this program is entirely valid and standard compliant. Now, just going down line by line, I guess I can go ahead and talk about it. So on line 1, you'll see that I say #include open open angle bracket IOStream close angle bracket. Now IOStream, or input output stream, is what's called a header file. And header files get included into CPP files, and they contain the definitions of a lot of functionality that we can use in our program. Now, IOStream happens to be part of a special library of code called the STL, or the Standard Template Library. Every programming language has a standard library. And when I say standard library, I mean it has a base set of functionality for performing things like input and output between, things like files and networks and other stuff like that, or console windows. And IOStream is part of the STL, and the STL is the standard library for C++, meaning the functionality defined inside of IOStream is actually very clearly defined in the specification of the C++ language itself. Segfault, I'm positive.
Well, it wasn't until you said that.
You what?
I said, or you were, until Segfault asked you if you were. Type.
Whatever. You do know that cout is a templated class, right? So it would make sense for it to be in the standard library. Anyway, so std or include IOStream is going to pull in a bunch of functionality that we can use to sort of interact with various input and output. In this case, we are going to be using a variety of console input and output using the cin and cout objects. So the #include directive is it's what's called a preprocessor directive, and it's basically going to take the contents of this file and it's going to dump it right here on line 1. So that's really cool. That gives our program functionality now that we need to use to interact with the console. On line 3, we have what's called our entry point. And our entry point is basically the point in which our program's execution starts. Now, the way that code is executed is code execution is the lines that our program continuously get processed by your CPU, line after line after line. But we need somewhere to start. And we start with this int main function. It's what's called a function. And it has a variety of characteristics that are true of all functions. For example, we start with the int keyword, which is what's called the return type, which we'll be talking about later once we start talking about what makes a function, followed by the identifier, or the name of the function. Now, this is important. It must be main. And the reason it must be main is because that's going to be the function that our program execution starts in. Now, we could just as easily have valid C++ with any name that we want, but this program won't be valid because it has no entry point. There's no place for our program's execution to start. So this name is very important, and it must be main. Following the identifier, we have these open and closing curly or open and closing parens, and the open and closing parens are used to pass in what are called arguments into a function. We're going to again be talking about that once we start talking about making our own functions. But it's important to know that these are required, and not only are they required, they can actually be used to allow us to receive data from the operating system if we wanted to. So on line 4, we have an open curly. And in any C-style language, whenever you see an open curly, what you're defining is called a block. And this block begins on line 4 and ends on line 9. Every method or every function definition, this is going to be really difficult switching from saying method to function. Every function definition is going to have to be immediately preceded by a block. And this block is going to start again with an open curly brace and end with a closed curly brace. Now, inside the block is where the executable code goes. So it's very important to understand that the block encompasses every line of code that we need to or we want to execute within our program. Somebody asked, aren't the terms method and function interchangeable? No, not in C++. In C++, the word function and the word method means two different things. In C#, there are no ways to define functions as a language feature itself. There are things called functions, but we're not getting into that. But in C#, pretty much everything is a method. In C++, you have methods and functions.
I did notice a couple of people asking about how to comment.
Yeah.
I imagine they're taking notes.
No, we'll get to that. Let's still try to follow our outline for the day.
I was just worried because I thought they're probably annotating their code, but with notes, if you see what I mean.
I mean, if you want to just show them a single line for the moment, that's fine.
Okay, so those are your comments. Comments are ignored by the compiler. So there are ways to annotate your program. Okay, somebody asks, about the difference between how they see .h sometimes at the end of their includes. The reason is generally speaking, you will have the extension .h for your headers. And a lot of the C libraries, in fact, I think all of the standard C libraries, which all of the standard C libraries are available for C++ if you want them, will generally be preceded by a .h. However, the C++ libraries, by some sort of convention I assume that they decided on, do not end in a .h. So this actually corresponds to a real file name. There is a file name on my computer called IOStream that is made available to my program for inclusion. If you wanted to include another file, you would have to type in the file's name, and per convention, header files should end in .h, unless you're standard C++ developers. Do methods involve classes? Yes. Okay, so yes, are there any other questions up to this point? C++ is not a class-based programming language. I don't know what you mean by that. C++ is pseudo-O, just like C# and Java are. Does it matter when the main function in lowercase, since the main CPP is with a capital M? It does matter. C++ is case sensitive and requires that main or your entry point is lowercase. Okay. So I'm going to delete nuke these for now. will we discover the difference between ISO, C++, and C++ CLI? No, we are not going to get into C++ CLI or any other of the C++ extensions. We're going to be talking about ISO C++. Just standardized C++. C++ is C with classes, right? No. It's part of it, but not the whole story. There's a lot of things in C++ that are very different from C that have not much to do with object-oriented programming. Yeah, it was actually C with classes was one of the original names, but he changed it probably because a lot of the features of C++ are not necessarily completely object-oriented. Okay, so now that we've opened up our block, so we've started we've started defining the executable code that's going to be executed when our program begins, we can now put in statements. And statements are really cool. Statements are going to be the instructions that we send to the CPU to run for us. Now, int main, this definition right here, isn't executable code. There's nothing executable about this. This is just a way to delineate what code we want to be treated as our entry point. So there's really no corresponding CPU instructions that come along with this. However, once we open up this block and start this function, we are actually defining executable code or instructions that are going to be sent to our CPU for processing. Now, the first one is going to look a little bit funky. And in fact, the way in which this works is kind of disappointing because we're not going to actually be able to break down the cout object in this course, like what we could do with WriteLine in the C# course, simply because this uses a variety of language features such as operator overloading, class instantiation, templating, and a bunch of other stuff that we can't fully explain in the beginning course. But you're going to have to take it for granted that the cout object applied with this operator will result in printing things out. This is functionality that's given to us by the IOStream header. And this is not magical special C++ syntax. This is a object. Cout is an object that is given to us by the IOStream header, and it is written itself in C++, meaning there's no special language feature that makes this syntax possible. This is simply the C++ people who standardized it, standardized C++ being a little creative with how they can express things. So we start off with this std : This is what's called a namespace. STD is called a namespace, and short for standard. And the STD namespace is a way, or namespaces in general, is a way to kind of group together things, types and variables and functions and type defs and all that cool stuff. So the standard C++ library is going to be almost always, without exception, unless I'm mistaken, is going to be wrapped in the STD namespace. And because all this functionality is wrapped with this STD namespace, we have to qualify that we want to use the functionality of the STD namespace in one of two ways. And this is the most simple way, where we simply qualify that we're accessing a member or an aspect of the STD namespace every time that we do use it. So in this case, we access two objects. We're accessing, with the STD namespace, we're accessing two objects. The first object we're accessing is the cout object. The cout stands for console output. And not surprisingly, console output is going to print output to the console. Following that, we see this operator. This shift operator is commonly used for binary operations, but is overloaded for this particular object in a way that will send whatever thing we pass into it to the console. So you can kind of look at this and say, okay, well, we have this hello world text and we're shooting it all the way into the cout object, which lives in the STD namespace. Or to say it the other way around, we are accessing members of the STD namespace by using this syntax. We're specifically accessing the cout object inside the STD namespace. We're applying an operator to that object, and we're passing in the text hello world to that operator. Can you put int main inside of a class? No, you cannot. Is the concept of namespaces in C++ different than in C#? No, not the concept. There are some neat little things you can do with C++ namespaces that you can't do with C# namespaces. But other than that, the concept is completely interchangeable. Do you have a preference using namespace std or just std::? We'll be getting to that very shortly here. Okay, so what we have here, though, is I said this was text. And text inside of programming languages, any programming language, I guess you could say, is going to be referred to as a string, or if you think about it, a string of characters. A character following another character, following another character, and so on until it terminates. All strings in most programming languages are going to be qualified with the double quote symbol. Some languages allow you to interchange the double quotes with single quotes. For example, in JavaScript, this would be a perfectly equivalent line. However, this is not valid for many statically typed languages such as C++ and C#. These have two different meanings. And as you see, I get this nice little error saying too many characters and character constant. Now, these double quotes define what's called a literal, meaning this data is being literally defined by our program and passed into another piece of the standard library. And the data, again, is simply going to be text. So we can place as much text as we want to inside of this. Now, on line 6, we do something weird. We do std cin.get. And std::cin is console input, or a way to get input from the user. Now, there's a specific reason why I'm doing this here. If I did not have this here, and if I try to run the program, what you'll see is, I don't even know if you guys caught that, but what's happening is the console window is opening up, the words hello world are being printed to the screen, and then the program is immediately terminating. Now, I want to point out that in the case of Ubuntu, or Linux or CDT in general, or in the case of Xcode, that even though the program still terminates, you can still look at the output down at the bottom of the screen. So if I jump over, for example, to Ubuntu, and I take off this std cin.get, and I run this, you'll see that the output is still made available to me. So there's no reason for me to halt execution of the program. Same is going to be true of Xcode. If I were to take out cin.get and hit run, you'll notice down here that the output was indeed printed out to the console window. So that's cool in these IDEs. And if you're using these IDEs, don't worry about the cin.get right now. But for Visual Studio, you're going to have to open up the right one first. You're going to have to use some sort of way to pause the execution of your program. Now, people have been repeatedly pointing this out, and I guess I should address it, that if you hit Control F5, you will get the output of your program followed by press any key to continue. Now, that's great, except for you don't get what's called the debugger attached to your program. And I prefer to be, when developing, always running my debugger with my application. So because of that, I have to put in std cin.get, which will halt the execution of my program until I hit the enter key, so that I can view the output of my program before my program terminates. So std cout or cout will print out stuff to the screen. std cin will get input from the console window. Of course, we're not doing anything with that input yet. We're just using it to halt the execution of the program so that we can view the output of it before it terminates. Now, in line 8, we have a very, very, very important thing. Moose asks, get isn't a function. Get is a method. Because cin is an object, get is a method. Okay, so on line 8, we have this return thing. And we are going to actually be defining what return means, how to use it, and where it's used, and what it's used for in our function overview later in this course. But for right now, you can think about return, the return keyword, and again, it's keyword because it's blue, and in the spec as a keyword. The return keyword will exit the current function that we're in. Now, the current function we're in is main. Again, that is the entry point to our application. The return keyword will exit out of that method. But most importantly, we specify right here this 0. Now, if we did not specify this, we would get this. Actually, we better get an error. There we go, good. Because if we didn't get an error, I'd have to go and slap Microsoft around for a while. Because I think like earlier versions of C++, Visual C++, this was valid only in the context of main because they're ridiculous, but regardless. We get an error saying that the function must return a value. So we must return a value. And the value we return is very important. The value we return is going to be sent back into the operating system to indicate a specific application-specific or a particular application-specific error message. 0 is the convention for your program has successfully executed. So if your program returns the code 0, that means your program has successfully ran, and the operating system can treat your program's running as a success. It doesn't need to display an error message or do anything like that or log any information because we returned out 0. So, are there any questions? And please put the questions in the question panel or else I will not probably see them because the chat is scrolling very quickly. Okay, so we have, is return 0 the same as return false? The answer actually kind of sort of is yes. But this is sad. I don't like that C++ treats Boolean literals as integral values. And as a result, return false not only to the eye of a programmer has the semantics of returning an error, but also isn't the correct data type that we're actually expecting. For those two reasons, I find this incredibly ridiculously messy and gross and disgusting, and the fact that the language supports it makes me upset. So please return an integral value from main. And the reason we do this, of course, is because main requires that we specify an int or an integer value as a result, meaning returning a result of any other data type doesn't make sense, even if it's allowed.
And you've got a couple more questions that have come in, and then we will we'll be pausing for a break.
Alrighty. Okay, so we have one thing I've been curious about in Visual Studio 2010. The C# version will alert you immediately when there's a typo, error, etc., but the C++ version only lets me know after I've built it. Is there some option missing on mine? No. The error reporting features of C++ are not going to be nearly as robust as that of C#. One of the reasons is because C++ compilation takes substantially longer than C# compilation. As a result, the Visual Studio as an IDE can continuously build your application in C# land and immediately get feedback that it can give to you, whereas the C++ IDE can't really keep up. Now, there are attempts in the Visual Studio 2010 Express to make this possible. So, for example, you see as I deleted this semi, I got this nice little squiggly on line 8 that says error expected a semi. And this is because in Visual Studio 2010, they wrote this nice little program that kind of sits on top of it, watches you code, and gives you suggestions. It's not a full compiler, but it gives you some of those instant error reporting features. That being said, you're not going to get nearly as nice of an error reporting experience as you would in C#. C++ isn't JITted. Well, it's not. I don't know what context that message was in. Okay, so does C++ have automatic error code for returns? I.e., if there's an exception, will it return something other than 0? Not entirely sure on that one. I doubt. I highly doubt it. If your program terminates, though, an exception will always cause your program to terminate if it's unhandled, meaning that your program won't have a return code because, well, there's nothing really to return if your program ends. I don't know if there's anything that sits on top of the execution that'll catch exceptions and change the error code or not. Isn't it more practical to put namespace std before the main function? Yes. We'll get into that in a second. What's the difference between functions and methods? Methods are a concept of object-oriented programming, and they are basically member functions of classes. So that might not make sense to you right now, but it will once we start talking about OOP. For now, we're just going to be worried about functions, which are free-floating, as in they don't belong to a particular class. Okay, so what happens if I return 1? Is that something for more complex programs? Nothing really happens when you return 1, but the program executing your program will get the opportunity to introspect that error code. And in some circumstances, I think that returning something other than 1 will result in something being logged to your event viewer, but I'm not entirely sure on that one. What about return null? Same thing. Exact same thing. This will work, but this shouldn't work. Because in C++, null is simply a constant for 0. It is technically an integer value, but it shouldn't be treated as such. It doesn't have the same semantics as an integer value. And the fact that this is legal, again, kind of irritates me, and I really, really, really discourage anybody from using null as an integer value. Null is a concept in and of itself. It has nothing to do or no logical correspondence with any other number or data type. How long will the class be for tonight? No idea.
Yeah, let me take a second to address that. As far as class times go, we record these and we make them available to people afterwards to accommodate those that need to leave early or come in late. As far as us staying to a very strict schedule, we do not do that. We have to log a time in the webinar system for how long the class will be. So I always put 2 hours in there, and there have been a few instances in the last classes that have successfully run, the last 6-week classes, where we've managed to keep it pretty close to the 2-hour mark. But most people prefer us not to stick to strict schedules for the simple fact that we spend the time answering questions, working with students, and helping people that are trying to learn, because, you know, that's what we're here for. We're here to help you guys, you know, walk away from these classes going, hey, I actually learned something. So I just wanted to let that be known for those of you that are new to sitting in with this class. Another thing I'll point out real quick is I got some feedback from Lori earlier about the questions, and I do very much appreciate it. With this being a free class and full of a lot of people right now, of course it is a little bit more challenging handling questions. That's why I love our member sponsor classes so much, because each class is a fraction of the number of people that are in there that we have in this class right now, and those go much, much smoother. And I believe there's quite a few people that are in here that could answer that right now. Where we've had some really good classes. What was that, Gavin?
I was just going to say, and also, this seemed to be the case of the C# course, and it makes sense really. But obviously, this is week 1. You know, we started from how to get hold of the IDE, so we need to make sure that everyone's up to scratch with this much at the very least, because everything else is going to rely on being able to open a new project, save a project, compile, you know.
Yeah.
These things we need to take the extra time. As the classes go on, they tend to the questions tend to sort of slim down.
Yeah. And then Jason just asked a question over in the webinar system about, can I join a class at a later date, say when you guys get to pointers? And the answer is yes. The only thing that coming into classes late for that would be negative would only be for those that are trying to get the certificate. And we'll spend time talking about the actual certificate portion of the program next Monday when we begin the class with the real students of the class. But it requires a 50% attendance along with doing homework and a final exam as well. So if you come in the last 2 weeks of an 8-week class, you obviously wouldn't have 50% attendance. But outside of that, yeah, we leave all of our classes wide open. So coming in as a member sponsor, you could take the UDK class, you could take the C# 102 class, you could take the C+ 101 class. I've also seen a few questions scroll by about, are we going to be getting into more complex stuff later with more advanced classes? And absolutely, for those of you that have been paying attention over on 3D Buzz, I posted a sneak peek at the C# 102 course that's coming up, and those are we're definitely taking things to the next level, and we intend to do just that with C++ as well. So I just wanted to answer those real quick. And with that, let's go ahead and take a 10-minute break. For those of you that want to get something to drink, use the bathroom, etc., because we've been going for a while now. And in 10 minutes, we will get right back on it. So here we go. Pause. Go. Okay, and we are now officially back from break. And let's continue.
Alrighty, so we have code on the screen. Just to recap. Line 1 brings in functionality from the IOStream header, which allows us to perform input and output against the console. Line 3 defines our entry point, signaling to the C++ language that we are about to create a function called main, which has special significance in the language. It indicates the entry point, or the first bit of code that the program is going to execute. On line 4 through 9, we have a code block. Now, this code block is parented to this line 3 here. It defines the executable code that goes inside this function. Line 5, we have an std cout method, or not method invocation, so actually an operator overload invocation, which passes the hello world string literal into the cout object that results in output being printed to the screen. Line 6, we invoke the cin.get method, which halts the console until we hit enter. And line 8, we exit out of main and we provide the return value of 0, indicating the program's success. Now, before I ask for any more questions, I want to introduce one little bit of functionality in the C++ language that we will be using quite a bit. And that's called the using namespace construct. Now, you'll notice that on line 5 and 6, I have to qualify that I am using the standard namespace to access either the cout or cin objects. But doing so is repetitive and annoying. And as a result, they introduced a language feature that allows us to do what's called import a namespace into being globally accessible within this code file. So I can go ahead and on line 3 here, I'm going to say using namespace std. Now, by typing this, the behavior of the program doesn't actually change whatsoever. I still hit F5. I still get the same output. I still hit enter and all that stuff. But what we can do now is we can omit the std qualifier from both lines 6 and 7. So I'm going to go ahead and nuke these guys. And you'll notice the code still compiles. And it still behaves just like it did before. The reason is everything that was an std is now available to us globally within the context of this single code file. So you can do either one. Now, if I was to omit this using namespace std, you'll notice that 5 and 6 immediately get squigglied because these identifiers are no longer defined because we're not qualifying what namespace we want to use. So far we have looked at 3 IDEs. We've started a project in 3 IDEs. We've written some code, and I've gone over each individual line of this file. Now, before we move on to any more additional features, are there any questions? Because next up is variables. Variables get very important, and that's going to be a massive context swap for people who are completely new. So I want to.
While you're there, do you just want to mention that block selection keyboard shortcut for Visual Studio, because it is a handy one?
Oh, yeah. If you hold on inside of Visual Studio and maybe other IDEs, I know Notepad++ does this as well. If you hold down the Alt key and click and drag, you'll be creating what's called a box selection, which allows you to type on multiple lines simultaneously. It's a cool little feature.
And Liam, the : yes, it is called the scope resolution operator.
Which in C# would be a dot.
Okay, you had a couple more namespace questions that have come in, Nelson.
And we got another, what's the difference between a method and a function? I've kind of sort of answered this in the past, but that'll make more sense once we get into object-oriented programming. The reason why this is a method and this is a function, think of it like this get method is owned by this cin object. This int main function is owned by nobody and is global to the entire program. Can namespaces be anywhere? Does it have to be in the include area? Good question. The answer is it can be anywhere. But it has to be anywhere before you actually use the stuff from this namespace. The reason I didn't know this is because I've never seen anybody put a using declaration inside of a block before, because I think that looks silly. If a namespace is conceptually the same as C#, then what is the difference the include and the using namespace? That's definitely not a stupid question. And if you all are familiar with I know a lot of you did come from the C# course, and you notice that we didn't use the include declaration ever. In fact, C# doesn't have one. Instead, we just said something like using names or using system or using system.io and all that stuff. And the reason is the way C++ compiles the code is sequential. What happens with line 1 is the include is what's called a preprocessor directive, meaning that there's a pass over your entire source code file that happens before the compilation step called the preprocessor. And whenever it sees hash include, it's going to take the contents of this file and dump it directly on line 1. Everything in IOStream will be dumped on line 1. And that's because in C++, you cannot reference code from other files or other libraries without saying that it exists. Because in C#, everything is compiled at once, and everything knows about everything else. The order that you define things does not matter. Everything is treated as a compilation unit, as an assembly. In C++, everything is treated as individual files that are compiled in a sequential manner, meaning everything has to be defined before you can use it. In C#, everything that you've referenced is available at all points. In fact, every bit of code that you have in your entire assembly is available at all points. In C++, that is not the case. In C++, you must predefine things before you can use them. And as a result, you have to bring in the definitions of everything that's in IOStream in order to have access to that functionality. And that's one of the things I kind of don't like about C++, and the reasoning behind it is actually historical, because back then they didn't quite have the processor power to keep everything that's being defined in memory at once. So there's a variety of different passes that the C++ compiler does. Will the namespace still be global if in the local block of code? I don't know. Again, I've never seen this before.
Well, I wondered about that because it seems rather like we're in C# doing a using stream reader.
Yeah, it looks like it is true. The namespace is going to be just within the block of code. And again, I don't recommend doing that. And please don't if you. It's just ugly and silly. And again, I've never seen anybody do that before. So how does a namespace behave? Well, a namespace behaves just like in C#. It's just that in C#, you don't have to include things into your files directly. They're global at all times, and all you have to do is import the namespaces. And we are going to be talking about the linker and object files later. But everything Segfault's saying is correct. Okay. So, any more questions before we get into variables? Going. Oh, header files are included with include, but other CPP files are included how? They're brought together by what's called the linker. That's a special step of compilation in C++ and C that kind of mashes everything together, and the linker figures out what goes where and all that stuff. But again, we're not going to be talking about the linker in this class. We will be in this course, but not in this specific class.
All right, let's go ahead and jump into variables.
Okay. As of right now, our program is kind of boring. It doesn't really do anything. Generally speaking, if you want to break a program apart into a very abstract sense, all a program is it's something that takes input from a variety of different sources. It performs operations on that input, and it produces an output. And at a very conceptual sense, every single program does this. There are no exceptions to that. But we need a way to actually store data in our program that can change between execution. We cannot guess what the user is going to type in, so we need some sort of way to represent the information that they provided us in a way that we can perform operations on. And that's going to be done with what are called variables. Now, I want to point out that variables in imperative programming languages, don't worry if you don't know what the word imperative means, but what I'm talking about is C, C++, C# for the most part. Those languages, variables do not behave the same way that they do in math. There's some similarities, but not entirely. They're not conceptually hot swappable. And the reason being is in math, when you declare a variable, you're kind of declaring a thing that you're declaring a truth, I guess you could say. But in languages, imperative languages like C++ and C#, you're not declaring a truth. You're allocating a location to store data that came from another source so that you can perform operations on it. So I just want to point that out. If anybody is familiar with math, it's very similar, but not entirely the same. Some languages do treat variables like that, mostly functional languages, but obviously we're not talking about functional languages. So a variable is going to always be two things at the very least. It is going to be a type followed by an identifier. Now again, because this is a statement instead of a block, I have to end the line with a semi. All statements are terminated in the C# or in the C++ programming languages with a semi. This is true for most C-style languages, including C and C#. Now, what we've done here is we've declared a location in memory that we can use to store data that the user might input. Now, as far as what a type is, you see that I'm using the integer type, or shorthand int. And a type is going to be an attribute of every variable you create that defines what that variable can store and how that data can be accessed and how that data can be transformed into other kinds of data. C++ and C# and C are all strongly typed languages, meaning certain instances of, it means that every variable must have a type. You can't have a dynamic type. Now with C# you can actually with C#4, but that's irrelevant. So we have this variable that has a type, and it has a type and an identifier. An identifier, whenever I say the word identifier, what I'm saying is we're declaring something and giving it an English name that we can identify that thing with. So as you see right here, int main is an identifier. We identify this function as main. std is an identifier because we are identifying a namespace that was declared previously. On line 6, we're using an identifier to declare a new variable that we can access within the scope of this function. Now, some of the cool stuff we can do with variables is we can print them out. So for example, I could say hello world, and then I can print out number. But this is kind of weird because as of right now, there is data in number. We made available to us data, but we have never specified what that data is. So if I hit run, you'll see a nice little runtime check failure. And this might be something new as of Visual C++ 2010, or maybe a previous version that I haven't played with before. But what's going on is this is actually telling us that what we're doing is stupid. Not all compilers will do this for you. Actually, this is just a sanity check. In the C++ language itself, there are no rules that specify whether or not a variable can be used before we stuff data into it. Now, this is not true for C#, for example, where every variable must be assigned data before usage. So how do we put data into this number? So we've made that space available to us, and we've given that space a name, but we need to be able to put data into it, and we do so with the assignment operator. So if I were to say number equals 10, at this point what I've done is I've assigned the data 10, or the integer constant 10, to wherever number is storing its data. So I've taken data right here, and I've stuffed it into the data, or the space that we've allocated for the data. Okay, can anybody guess the output of this program? And I'm not talking to you, Segfault. All right, cool. It looks like everybody got that right. And you might be people who got that right might be, ooh.
Not in questions panel.
All right, sweet. Well, that actually brings up a good discussion then. This is this process of sequentially executing code is the first concept that is very important to learn. So if I run this program, we'll see the output of 10, or more specifically, hello, comma, world, exclamation point 10. What is going on with this program is execution starts inside of main, and execution goes sequentially, meaning it starts on one statement and then continues to the next statement continuously until the end of the program is reached. So the first sort of conceptual thing that is very, very important to understand is that the state of your variables on one line only is relevant to that one line. And if the state of your variables were to change over time, it's not going to in any way impact the state of the variables as they appeared previously. Meaning, on line 6, we define an int number. Now, this actually isn't executable code. We're simply informing the C# or C++ language that we want some space, some memory allocated for us that can store an integer value. And we want to call that space number. We want to refer to that space as the name number, the identifier number. On line 8, we store the integer literal 10 into whatever space the C++ programming language made available to us and named number for us.
Now, you've used that term literal a couple of times. Do you just want to clarify for people who don't know?
Yeah, for the word, when I say literal, I'm literally using the definition of the English word literal, but also has the same meaning in the context of programming. A literal is a piece of data that the C++ program understands as being a literal constant, or we are literally saying 10. It's never going to be anything other than 10. It's a literal constant. Now, we have 3 literals in this, or 4 literals in this program. We have the value, the integer value 10, the string value hello world, the integer value 20, and the integer value 0. Those are all literals because this particular syntax, by just typing a bare number, has special meaning in the C++ programming language, meaning that whenever it sees a bare number like that, it treats it like a literal piece of data. And fortunately for us, the C++ language designers decided to use base 10 for their, by default for their literals. So as a result, 10 literally translates into the decimal value of 10. For people who got the uninitialized number instead of the exception, again, that's probably some setting or something that my instance of Visual Studio is adding onto my code. It's not in the spec that that you have to assign a variable a number before you can use it. This is just some sort of sanity check that Visual Studio is giving me. I really wanted to see what you guys saw myself. I didn't want to see the exception, but it put it in there anyway.
I was going to ask about that because obviously in C#, if you did that, you would get a 0.
No, you get a compiler error. If I did this, the C# compiler would say this variable is not definitely assigned, therefore it cannot be used until you assign it to a value. Even though it technically still is 0, so if you opened up a debugger and looked at it, it would still be 0. It's still,
okay.
the compiler itself has that sanity check. Okay, people are telling me to click continue. Or oh, okay, there we go. There's my uninitialized variable. And continuing after an exception makes me feel very uneasy. C++ exceptions are not very pretty, and we'll be going over at some point in this, the course is coming up about the ugliness of C++ exceptions. But okay. So, okay, so what's going on here, just jumping back into the discussion before, we have a variety of statements here that are executed in sequence. Now, line 6 isn't actually executed. Line 6 is a declaration. It simply means C++, give me some memory to stick an integer value into and call it number. On line 8, we are saying C++, take the literal 10 decimal value and stuff it into the memory location that you gave us for the number variable. Line 9 says, cout, go ahead and take the string hello world, the string literal hello world, print it, and then take the value inside of the number variable and print that. Line 11 says, okay, C++, take the integer literal 20 and stuff it into the memory you gave us for the number variable. Line 12 says, okay, cin, go ahead and get. And then once you're done, line 14 says, okay, C++, we want out of this method.
And in line 6, the identifier is the number, is the name number. Oh, that's a confusing sentence.
When you return 0, does your program release the memory it was using? Yes, it does. The operating system, well, your program doesn't, the operating system does. I do want to point out, though, that none of this is dynamically allocated. We are not using dynamic memory allocation yet, meaning that all of this code, the memory required to run this program is actually allocated when the program begins. And we're not at any point asking for more memory during execution. So I want to make that distinction right now, that we're not really using anything that the C# garbage collector would be used for, nor are we doing anything that would make it possible for a memory leak to occur, unless there was a memory leak in cout or cin.get. Now, main is a function. cin.get is a method. Liam asks a good question. Can you declare and initialize on the same line? The answer to that question is yes. If you wanted to, simply, instead of terminating the line, you could simply say int number equals 10. The reason I wanted to separate it out is I wanted to make the distinction that int number is not executable code, but instead is an instruction to C++ to allow us enough memory to store this data. However, saying int number equals 10 adds a bit of executable code to this particular declaration, where not only are we asking C++ for memory to store this variable, but we're also telling C++ what to stuff into it. Affixi, yes. Everything that you see in this program is entirely on the stack. The Relentless asks why we're getting the same garbage number. Answer to that question could very easily be, so that's 858. I think I know the answer.
Is that the minimum possible?
Minimum possible?
I mean, is it just displaying the minimum possible value?
No, it is displaying a garbage number. That is uninitialized, but it could very well be simply because the runtime has allocated some memory before our main stack frame got pushed on. That's simply consistent with everybody's runtime. Alternatively, it could be a flag that Visual Studio, when in debug mode, inserts into your program so you can know if you're using uninitialized values.
Yours did actually change in those 2 times you ran it there.
Yeah, I did notice that. So when I run it outside of debug, or if I take off the initializer, of course, we get a different garbage value than if I ran inside of debug. So that's 858, and in this case, I get, or whichever.
What happened was your key that you hit was getting displayed. That's what confused me. Sorry. Oh. You hit the G key and that appended a G to it.
Well, the point is that it's going to be undefined. Now, because it's similar between all of our environments doesn't mean that it's not, it is defined. It is by definition undefined. And there's a variety of reasons why we might be getting the same result, whether because the existence of the debugger or the fact that we're building a debug mode out of our application. So if I were to change this to release, we might get a different number. Yep. Notice how I change it to release mode, and now I get a different number. The point is that's undefined. You should never use an uninitialized value. Okay, like Unreal confirmed my suspicion that uninitialized values are initialized to some default, so you can tell they're uninitialized while inspecting, which makes perfect sense. The point is never to use them, though. Okay, we are getting a bit off track, though. So, Bob Reg, yes, you notice on line 6, I took the initializer, or I took the assignment and I turned it into initializer. An initializer is simply a definition of a variable in addition to assigning a value to that variable. Also, to define variables, we can use function notation, right? I'm not sure if that is allowed for the primitive types. It is allowed for the primitive types. So yes, you could use this, but I find this is incredibly ugly. The reason I find this is ugly is this is also the syntax to use constructors for not instantiating, but creating classes on the stack. I would not recommend using that syntax.
So just from a readability standpoint?
Yes. If I saw this, my mind would instantly go to you are using a constructor of some user-defined type.
Yeah.
I think it would be silly to use. Is it better to declare than initialize on a separate line? Generally speaking, you should initialize on the same line as your declaration, especially in C++, because using an uninitialized value is a possibility in C++, whereas it is not a possibility in C#. So you will not be informed until your program executes that you are using an uninitialized variable. Yeah, remember, C++ is easier to kaboom, pretty much. Destructors do get invoked on local instantiations. Line 12 is 10 is acceptable? Of course it is. We can reassign our variables to different values, which again kind of gets away from the mathematical definition of what a variable is. Because our variables aren't so much a truth about some logic as they are a thing that can change over time. And again, that's not true for all languages. Some languages, once you define a variable, you cannot change it. Nothing shows up when I select the class I want to enter. What? I'm not too sure what he means by that. Okay, so what's happening here is that on line 10, so just to recap this, I know we kind of got sidetracked a little bit, but on line 6, we initialize and declare a variable called number, and we assign it to the value of 10. On line 8, we tell cout to print out hello world, the hello world literal, and the number variable. So this means that this variable will pass in to cout whatever value it is at the time that cout was invoked, meaning at the time line 8 is executed. After line 8 gets executed, we immediately go into line 10, where the value of number is changed, but that has no correlation whatsoever to what happens on line 8. Because it's happening after line 8 is executed, we can change the value of our number variable to whatever we want, and the behavior of cout does not get affected.
It's just like the real world.
Yeah.
You know, if you've got a piece of paper and that says hello world, and then you show it to someone and then change what's written on the paper, they don't know what you've changed it to.
Right. There's no correlation because it's a sequential process. What's the difference between the int on the main function and the int in the variable? Good question. The difference is the context that this appears. Now, the int in and of itself has the same meaning on both these lines, meaning we are still referring to the identifier integer, or shorthand int, which is part of the C++ specification, which indicates a particular type of data. However, in a more contextual sense, they are completely different in that the int here on main is specifying the data type that main is going to pass back to the operating system. Now the specification, the C++ specification requires that main has the type of int. There's no proper standardized alternative. That's being said, there are some compilers and earlier versions of C++ that allow you to either omit this or use void. However, neither of those things are standard C++ and shouldn't be used. On line 6, we are declaring a variable and we're giving it the type of int. Okay, are there any more questions about line 6, line 8, and line 10, and how the variable sort of interacts with the program? Because I noticed there were some people who did say that the output should be 20, which is great because I just wanted the opportunity to just sort of try to beat, you know, this sequential flow of a function into people's heads, and I'm wondering if people need more clarification or not.
I think you've made it pretty.
Huh?
I think you've made it pretty clear.
Okay.
But Nelson, what happens if I want to store a value for pi? Can I put that in an int?
Well, you'd be unsuccessful. If I wanted to, now remember how I said variables are defining the kinds of data that can go, or types of variables, define the kinds of data that can go into that variable and the functionality that that variable has in relation to other things. If I wanted to store a decimal value inside of an int number, you'll notice I get a nice little successful build, but a nice little warning. Yeah, the really, I guess the really liberal way that C++ treats data is irritating to me. But fortunately, we have some warnings that we can look at to give us a hint as of something that we are doing wrong. Now, given this hint, and I'm going to open up my error list so you can see it a little bit nicer. Given this hint, warning, initializing, conversion from double to int, possible loss of data. Can anybody guess the output of this program?
It's not so much, C++ is much more like just some bloke stood behind you going, oh, you don't want to do that.
Yeah, but then it'll let you do that.
It's like, it'll let you.
The question was, what's the output of this program? The output of this program in C# would be a compiler error, but as you see right here in C# or C++, it's just a warning. Okay. So you'll see the result is Hello World 3. And the reason why it's 3 is because when we are stuffing this data or this double literal into this integer variable, we are getting a nice little thing called an implicit conversion, which takes the data that we are trying to stuff into the variable and does its best to sort of put it into that variable, even though it might not totally fit. And the reason it might not totally fit is an int data type only supports putting in numbers, positive or negative, that are whole. As a result, this data type disallows any decimal or fractional data attached to it whatsoever. However, you'll notice that, so, oh great, now I'm not even getting the warning anymore. There we go. Can any of the complete beginners, so only if you are completely new to programming, answer this question? Tell me what line 6 should be in order to get the output hello, comma, world, explanation, space, 3.14. What should line 6 be? Given the warning that I have highlighted down here, what should line 6 be? Alrighty, so we have a few different choices here. Some people said do float number equals 3.14. Some people said do double number equals 3.14. Some people said do int double number equals 3.14. Int float number equals 3.14. Some people said float number equals 3.14f, which we haven't covered at all. But the answer would be, in this case, to get this program to compile with as fewest changes as possible without producing any warnings, the answer to this question would be to change the type integer, which is a data type that only contains can contain whole numbers, and change it to another type that can support this sort of data. And if you look at the answers right in this warnings, that's why, although it was a bit of an evil question for people who haven't programmed before, the answer is kind of right here if you read this. It says initializing, conversion from double to int, possible loss of data. So we can infer from this warning message that this value right here is a double literal. It's no longer an integer literal, it is double literal, meaning the data type that C++ wants us to use when using constants with a decimal value is going to be the double type. And what we can do is simply, instead of using the integer data type, we can use the double data type. And if I build now, you'll notice I get no warnings. And if I run this program, you'll see 3.14 properly outputs to the screen, meaning this variable is now capable of storing data that has a decimal value. To the people who answered with float, if I run this program, you'll notice that there's still a warning. And one of my things was there shouldn't be any warnings. And the warning is initializing, truncation from double to float. However, the output will still be right. But I'll go ahead and talk about what this warning means in a second after I answer some questions. Okay, is there a difference if I use 3.14 or 3.14? Now this is going to be an interesting cultural difference, but the answer is that the C++ language specification, which is global among all cultures, is going to use the dot notation to indicate a decimal value. There's no way that I know of to make C++ treat a dot as a comma. Yes, Unreal. We're going to get to that, actually. That is one of the features of C++ 11 that we will talk about. I don't think in this class, though. Okay, now this double data type is very interesting. This double data type allows us to store data that has a decimal point. But there's an important attribute of this type of data type, and that is what's called precision. Now, if you recall, when I said that when we have a variable definition in a function, we are indicating to C++ that we want a specific amount of memory to be available to us as our program executes. So we can use that memory as sort of like Scratchpad as our program runs to keep track of different things that are happening. As a result, every variable or every type has a finite amount of data that it can store. And of course, I'm referring to built-in types right now. I'm not referring to custom types, which you can mimic the appearance of having more data available for it. But we're not going to be talking about that quite yet. So because everything is finite in programming, there's nothing that's infinite in programming. We only have a specific amount of memory available to us given a particular type. Now, the float type allows us to use less memory than the double type. As a result, the float type has less precision, meaning it can store fewer significant digits than the double type. So when people said use float number equals 3.14, this isn't necessarily correct because we are indicating to the C++ language that we want to allocate as much memory as we need for a float, but then we're stuffing a double literal in it. And the reason this is a double literal is C++ treats any number, any naked number with a decimal point inside of it as a double value. However, some people did ask, what if we could do this? The answer is yes. By adding the F suffix, we have changed the type of this literal to a float and therefore allowed an implicit conversion, or not an implicit conversion. We don't need to convert anything because the value right here is of the same type as this variable. Okay. Would you be able to change the int number 3 to a double number 3 later in the program? The answer is no. There's no way to change a type of a variable after it's been defined. Now, that's not true for all languages, but it's true for C# or C++, and consequently C++ or C# and C.
If you go back to the int, version of it with the decimal, yeah, and change the 1 to a 9?
No, it's going to truncate it. That's a good point.
I wondered.
The behavior of assigning a floating point number, whether that floating point number is in the form of a double or a float, is going to be truncation, meaning this data after the decimal point is completely lost. And by the way, the reason it's called a double, this is called a float, this is called a double, is because a double stores twice as much, or allows twice as much memory for storing its data, meaning it has twice as much precision as a float.
Does C++ have a single keyword?
No. Well, C# doesn't either. It's actually the type in the BCL called single.
Yeah.
Which is really confusing, but whatever. Alrighty. So that was just a quick overview of variables, the data they can store, and the difference between two particular types. Is everybody good so far? Because now we need to get into user input. Somebody asked, double takes 8 bytes of memory, is that right? Yes, at least on this architecture it does. A 64-bit architecture. And a float takes 4 bytes, so does an int.
So Nelson, cin.get is an odd name for something that just stops operation. Does it do more than that?
Yes, it does. Now, actually, we aren't going to quite go into this particular method because look at these terribly, awfully intimidating signatures. Look at that.
No.
Look at that. I mean, really, C++? Come on. But we will be talking about the cin object, I guess, right now. The cin object, or cin object, is going to allow us to do user input. You'll notice that this program is very boring. And although we have variables, these variables are meaningless because they never change between execution of the program. So let's go ahead and talk about cin. Cin is an object that allows us to grab data from the console window. So let's go ahead and I want everybody to type this out.
So if you're following along with this, raise your hand in the webinar, and then, more importantly, don't forget to put it down again once you've typed it all in. And we'll know we're ready.
If Nelson thinks it's bad, what does he think of expression templates? I was just kind of poking fun at C++, and the reason is actually I do understand what this is and what it does and what you can use it for. My problem is that both cin and sout, or both cin and cout, are see, that's how I pronounced it in my head for like 8 years, cin and sout. I don't know, it's kind of silly, but anyway. My frustration is with teaching this to people who are new is that the concepts right here, traits, templates, pointers, references, this stuff is so far advanced that people aren't going to be able to understand even the signatures of the methods they're using until they learn a lot more about the language. Contrast that to C#, I can point at console write line and say, that's a static member of a static class that writes out to the console, and they're, that makes total sense. But you look at this and it's like, what? Chris asks, are these operators pointers that we keep on hearing about? The answer is no. These operators are called the bitwise shift operators. And they actually have behavior in a mathematical sense, and they also exist in C#, if I'm not mistaken. But they do actually, yes, I'm stupid.
Yes,
they're the bitwise shift operators, and they're kind of being misused right here. This is an example of operator overloading that I dislike because they're using them in this sort of non-math oriented way in order to indicate data that we're passing into these objects, which I personally don't like as much. But these are not pointers. These are simply operators, mathematical operators that are overloaded to behave differently in the context of these objects.
So that's actually not an overload to bit shifting then?
No, it is an overload.
Wow.
They overloaded that operator on the
Just
cout
because
object.
it's a picture of arrows.
Yeah.
There's just half a dozen people or so still typing. Remember, once you've finished typing, lower your hand again. Oh, no, somebody missed something.
So if it's an overloaded method, why does it have parentheses? Good question. This isn't really something that I wanted to talk about here in this course or in this particular class, but just to answer your question, they're not overloaded methods, they're overloaded operators, which allows you to invoke methods without specifying parentheses, essentially. You can think about it like that. We are maybe in the C++ 504 class, we'll get into STD character traits, and we will be into references at some point, but eventually, yes. But this templating and traits are not something we're going to be talking about in the 100 series, or probably even the 200 series, or maybe even the 300 series. Because that stuff really will twist your brain into a knot.
Gamster and Piotr, if you're still typing, could you indicate as such? Otherwise, we'll have to assume you've gone AFK, I think.
Segfault, you can overload new, and you can overload delete, which makes me cry. You can overload new globally, and you can also overload new at a class-specific level, because that sounded like such a great idea to the language designers. Actually, in all honesty, overloading new and delete does have its uses. You can use it to find memory leaks.
I think that's probably.
So yeah, let's go ahead and
let's
go ahead and continue, Nelson.
Okay, so if I were to run this program, Segfault, no, you need auto pointers for that. So let's go ahead and run this program, and I can go ahead and type in my age, and nothing happens afterwards. Let's go ahead and actually make. Okay, so yeah, let's go ahead and print the answer first, so we can get some level of interactivity with the program, and run this. So type in our age, and actually, great. Okay, can you pause really quickly? I forgot about something.
Okay. We're resumed.
Okay, so the problem that I completely managed to forget about somehow between doing the course and preparing for it was that by hitting enter right here on line 9, we are inserting a new line character into the character buffer, and that new line character isn't getting eaten by this invocation of cin. As a result, that new line character is still sitting on the cin buffer, meaning that when I do cin.get on line 13, it's going to return the last character that was added into the buffer, which means when we hit enter, line 13 just gets skipped because the new line character gets eaten by cin again. So to ignore that new line character, we can say cin.ignore prior to saying cin.get.
So what you're saying is when you get the line 9, when it's smart enough to know that the new line character isn't part of the int.
Yeah.
And it's kind of left behind in assigning
Yep.
it to the int. Okay.
Yep.
That makes sense.
Just left behind, and then cin.get says, oh, you want the latest character in the buffer? Here, have a new line. Okay, so now if we run this program and hit enter, we get input and output, which is very exciting.
I'm excited.
Are you excited? You should be excited.
I am.
So yeah. So what's going on here is we are creating a variable. We are declaring a variable called age, and we are asking cin to fill it with data from the console. Immediately afterwards, we are telling cout to print that variable back out into the console for us. Now remember, this is a variable, meaning it's simply data, or it's simply a location in memory that we can stuff values into. And here we're deferring to cin to stuff a value in for us. And the result of this is going to be printing out to the console. So here on line 11, we go ahead and we print out this string followed by this integer followed by this string. We inform cin to get rid of anything in its buffer, or actually I believe ignore gets rid of the last thing in its buffer. Then on line 14, we say cin.get. So we now have a successful program, but what if we wanted to do a little bit more interesting things with our variable? Well, what?
I was just going to say, thinking back to your previous example, if now you added in at line 10, age equals 20.
Oh, right. Yeah. So what should the output of home? Yeah. Anybody who up till today has not worked in a programming language or is at least relatively new to programming, what do you think the output on line 13 will be in this program? Sweet. Well, we did get a few people who said that the output should be whatever we typed into the variable, but if you'll notice, if I type in this and hit enter, it says, hey there, you entered 20 as your age. And the reason that's happening here is because on line 11, we are taking whatever data that cin stuffed into our age, and we are replacing it with our own integer constant. That integer constant is 20. So does anybody who answered anything other than 20 in the last question, do you guys sort of understand what's going on at this point, or is there any part of this program that's making it confusing? Alrighty. Alrighty, so I do want to point out one quick thing before we get into the last section of our class today. Just to have some fun, just to show people, kind of get people to think about the variety of ways that they can use data within their program. Okay, so remember, the goal of a program is to take input, perform an operation, and write output into the application or into whatever medium that you're using to write output to. What we can do with data, though, is we can transform it in a variety of ways in our programming language. And that's pretty much the goal of any programming language, is to allow us to get data from the user in some sort of way and perform operations to it. So as you see right here on line 11, I've actually performed what's called an expression. And we kind of been forced to use expressions up until this point with cin and count, or with cin and cout. As you see right here, we're using the bitwise shift operators to perform input and output, but we also have a variety of arithmetic operators. In fact, all of the arithmetic operators people would be familiar with available to us. And we can perform those arithmetic operators on either variables or integer constants or float constants or double constants or whatever other kinds of constants that the language allows us to express. So in this case, what we have here is we have an expression that assigns the result of this expression to, or an assignment statement that assigns the result of this expression to the variable age in 1 year. So now we actually have a little bit of logic in our program that allows us to get an interesting result. So if I said I was 30, my program now informs me with incorrect formatting. My program now informs me that next year I'll be 31. So we have this really awesome, bit of logic in this program now that's performing a useful result. So yeah, any questions about basic arithmetic operations? Because then we're going to jump into control flow.
Did you cover, sorry, does everyone know what a modulus is? That's the only commonly used one that people don't commonly know about, if you see what I mean.
Yeah, there is a modulus operator. I don't know if we were.
No, it wasn't.
I'm basically.
Oh, okay, sorry.
I can just quickly define it. Basically, it just returns the result of, or the remainder of, a division operation. Alrighty. So if statements.
Times.
You what?
Sorry, you left that on times.
Okay. So, conditional statements. Conditional statements are really interesting because basically, as of right now, every bit of code is being executed in main sequentially, starting on line 6 and ending on line 16. So we have 10 lines of, well, we only have 1, 2, 3, 4, 5 lines of executable code, but we have code that's executed in sequence. But we can actually make it so that our program takes a different branch of execution if a particular condition is true. So what we can do is use what's called the if statement. And the if statement is really cool, and you will be using it everywhere. The if statement starts with the keyword if and follows with parentheses, which I'm not going to fill in yet. This will be an invalid construct for now until I fill something in here, but I'm going to leave it empty for now. Now, after the parentheses, it follows a block. I want to point out that this is an incredibly common pattern that you should get your hands familiar with typing as soon as possible, because almost every single control flow statement inside of C++ or any C-style language is going to follow the pattern of keyword, parentheses, and block. So what goes inside of this? Basically, what goes inside of the parentheses is an expression that's going to be evaluated into true. Now, C++ has is very, very, very incredibly, ridiculously, stupidly, sometimes not productively, liberal about data that we can place into our expressions. As a result, in C++, the numeric value 0 is false. Everything else is considered to be true. So we can do this, for example. Notice that this compiles properly. What does anybody think the output of this program would be? And I mean the output of the program after the age has been asked for. What about now?
So you could put something horrible in there, like 10 over 2 minus 5, and it would,
Yeah, this would result in 0. 0 is false. If 0 is false, this block does not execute, and this code in this block is ignored. So I wanted to point that out, that there is a direct correlation between numerical values in C++ and truehood and falsehood. But I really want to stress the fact that this correlation that exists in the language specification is not as useful as you might think it would be, and in fact leads to lots of confusion, which as a result, a variety of languages have made this sort of implicit conversion impossible. But in C++ it is possible. So let's talk about truehood and falsehood, at least in the context of a Boolean. A Boolean is another variable type that can either be true or false, or 1 or 0 in the context of C++. There are a variety of operators that allow us to create an expression that returns either true or false. And there are a lot of common operators that I'm sure a variety or many of you are familiar with. So for example, what we can do is we can say if age is greater than 10, we could say you are older than 10. We could also say if age is greater than 30, older than 30. So we have the greater than and less than operators that allow us to construct expressions that return either true or false. And because these expressions return true or false, placing them inside of the parentheses of an if statement allows that if statement to conditionally execute based off the value of the expression. So if I run this program and I say 20, we'll get you are older than 10. Now we don't get you are older than 30, of course, but we do get you are older than 10.
but what happens if I do? What happens if I do it and I'm 35?
If you type in 35, you get this. You're older than 10 and you are older than 30. I do really want to quickly point out something. You'll notice that these two things are on the same line. You don't have to remember this or commit this completely to memory, but this is going to be very important. The /n escape sequence will allow us to create a new line inside of our console window. So by saying /n, we are effectively adding on a new line that allows us, well, that's a bad example, of course, that allows us to print each one of these expressions on new lines.
But see, if you had one of these for every year, you'd end up with a lot of output. You get you're older than 1, you're older than 2, you're older than 3. Is there any way of just having the one output?
Well, yes, there is. What we can do is we can do a few things. We can invert this and add this as a condition. So we can say if age is, hold on. We can say if age is greater than 30, and then if age is greater than 10 and age is less than or equal to 30, you'll notice what we've effectively done is we've nested in these ifs, and we've created a situation where we have this block that's parented to this if statement will be executed if the age is greater than 30. This block will be executed if the age is greater than 10, but we want this to be printed, this text to be printed only when the age is greater than 10, but less than or equal to 30, because we don't want it to execute whenever this executes. Whenever this block executes, we want something else to execute, or we don't want them both to show up at the same time, to say it in English that doesn't suck. So what we have to do is we have to nest another if. We have to say, okay, so if this condition is true and the inverse of this condition is true, then we know that either one of these will be printed, but not both at the same time. So we could say, if we're like, 600, we only get you are older than 30. But if we have 20, we get you are older than 10. However, there's a better way to perform this logic. And the logic that we want to say this in English, to say the logic we want to express in English, we want to say, if age is greater than 30, print this. Otherwise, if age is greater than 10, print that. And there's a nice little synonym to the word otherwise called else. And that happens to be a keyword in a variety of programming languages that support if statements. And it gets typed out like this. By specifying the else branch, which is only valid to be done immediately after the block of the if branch above it is closed, we are specifying code that will only be executed when this code is not. Meaning we've now created a situation where either one of these will execute, but not both of them simultaneously. Meaning if I hit F5, we can type in 20 and we get you're older than 10. But if we type in 500, we get you're older than 30. So that's a cool little thing that we can do in the language.
So in C++, you need the curly braces after else?
No. I mean, I am kind of torn on introducing this just quite yet, though, because not having the curly braces for single expression else blocks will confuse people, undoubtedly.
Actually, that wasn't where I was pointing with that one.
You mean else?
Is there no else-if construct in C++?
Well, it is in the outline. So I guess I could. This scenario is so common that instead of performing this syntax, you could simply do this. By providing the else keyword, a space, and then the if keyword, you are not only specifying an else block, but you are also adding another if block to that else block. Okay, so, yeah.
Now, there were a few other things, Nelson, that we were going to talk about that we have in the syllabus with ifs that we wish we would have talked about in the C# class early on, such as logical operators.
All right, so I'm sure most of you are familiar with a few of the binary arithmetic operators. At least I hope most of you are familiar with these, like plus, minus, divide, and multiply.
Okay. What does definitively? What does a binary operator mean?
A binary operator is an operator that takes in two operands. So for example, the reason why the plus operator is binary is because you specify two numbers to be added together. Each one of these things is called an operand. And because the binary operator plus is binary, it requires the presence of two things in order for it to work. It doesn't make sense to add something to nothing. Same thing with subtract, multiply, and divide.
So is there such a thing as a unary operator?
Yes, there are negation operators such as that, and there are logical not operators. So in that case, we have negation, logical not. We have XOR, but I'm not going to be talking about that. Or XOR, stupid keyboard. There you go. But we're not going to be talking about that in this one. But yeah, these are the main unary operators that you would want that only require one operand. But there are some what are called relational operators that are binary. They're binary operators, but they provide us with the ability to compare two things for truth. So, for example, there is the greater than, the less than, the equality, and the inequality. These are going to be the primary relational operators that you will be using. There's also the greater than or equal to and the less than or equal to. So this means that if 10 is greater than 3, we get the message being printed out because 10 is indeed greater than 3. So these relational operators can be used, and they are binary in that they require two operands. So memorize these operators: greater than, less than, equality, inequality, greater than or equal to, and less than or equal to.
Can I just home in on the equality for a second?
Yeah, I actually want to do something really quickly here for people. Alrighty, everyone. Although this is in valid C#, it is valid C and C++. What is the output of this program?
Also, I'd like to say I like the word Truehood.
Truthhood?
True. You said Truehood when you earlier when you were talking about Truehood or falsehood, and I thought it was quite nice.
Oh, it looks like we have an argument going on in the class. I mean, not like an actual argument, but people are like, it's true, it's false, it's true, it's false.
Excellent. That's what we're after.
All right. Well, we go ahead and nuke this program, and let's see what gets printed. Absolutely nothing.
Boom.
The reason this printed absolutely nothing is because a number is set to 0, but then inside this if statement, or this, inside this if statement, inside the conditional expression here, we are not using the equality operator. We are using the assignment operator, and we are assigning the value 0 to the variable a number. Because we're assigning the value 0 to the variable a number, the result of this operation in its entirety is going to be the value 0, because 0 is being assigned to the value, and the value of an assignment operation is whatever the thing was assigned to, meaning the value of this expression is 0. And because the value of this expression is 0, the result is that the if statement does not execute.
The key point being the equality operator is two equals symbols.
Yep. So if I were to instead add another equal sign to this, we will get a completely different result of our program. We will get a number 0. That's because we are comparing, because the two equality symbols, or two equal signs, we are comparing the value 0 with whatever value is contained in the a number variable. So it's very important to keep in mind. Okay, so as far as the other relational operators, greater than, less than, equal to, not equal to, greater, equal to, and less than or equal to. So they all do exactly what you'd think they would do. So if I said a number, if a number is greater or equal to 0, I can say a number is greater or equal to 0, and so on and so on. We haven't quite talked about the unary not operator yet. I don't know if we already are like
Right. Let's go ahead and hit the our logical operators.
Alrighty. Oh, sweet. Because somebody just asked a question that'll lead right into that. Somebody just asked the question, what if we did a number equals 5 and a number or 0 is greater than a number is small, there's greater than 10. And
less than.
Or less than. Words are hard. So this will work as you would expect it to. But there's another way to test if something is in the range of something that'll be more familiar to programmers than this sort of syntax. So what we can do instead here is we can say if a number is greater than 0 and a number is less than 10, or less than 10. So what we've effectively done is compared a range from 1 to 9. And the way we've done this is with the logical AND operator. The logical AND operator is going to be, if this expression is true and this expression is true, then the whole expression is true. So what we could do also is we can use the logical OR operator, which is 2 pipe symbols. This logical OR operator means if this is true or this is true. So it kind of reads out like English. So the operators that people should really keep in mind are greater than, less than, greater than or equal to, less than or equal to, not equal to, and OR. Actually, the precedence is, that's actually the correct precedence if you're thinking in the right order.
Yeah, and actually, if you include normal parentheses, you've covered basic order of precedence. And
The what?
if you include parentheses, you'll have covered all the basic operators.
Oh, right. Well,
it's just we didn't in the C#, and it's one thing that.
S2 XI asks if the literal and or is allowed, and the answer is no. Now, with the preprocessor, we can make this work, but we're not going to because that'd be ugly. Just use the, just like what Segfault just did. Please use the actual symbols for indicating and or. Alrighty. So yeah.
Yeah.
Is there anything?
I think that pretty much takes care of everything that we had lined up for today. So,
So sweet. I mean,
cool.
Are there any questions? Nelson, can you do if age does not equal null and then input 0? Huh? Well, yes. Instead of 0, you can use the constant null I just want to point out that that's not what null should be used for. We haven't gone over what null should be used for yet, and we won't until we get into pointers. But although null does resolve to 0, as does false, conceptually, null and false are not data types that should be treated as numbers.
And somebody asked, the exclamation point means not. So exclamation point equals is not equal to.
Yep.
So we will be repeating this class again this Friday. For anyone who wants, you guys are more than welcome to come back and join in. The content is always going to change a little from class to class because we have an outline that we follow, but the examples are just pretty much made up on the fly, which can be quite handy sometimes.
Yep, and we also have different people asking different questions.
Absolutely. Yeah, K7, 3, SK, 11, and the rest of the alphabet. Yeah, basically Monday and Friday classes will be just different sessions, same class. So the real week 2 will be next Monday and then next Friday.
But just out of curiosity, did any...
Well, hang on, no, K7S or K73SK, you're right. I should have pronounced that as William. My bad. I'm just messing with you.
But yeah, just out of curiosity, how many people who were new to programming got something out of this class today?
Ooh, that's a real good question, Nelson. Sweet, Surreal did. So that makes it a perfect day. Actually, it looks like several people. That's awesome.
I don't find C++ syntax as horrifying as I used to.
You're going to see a lot of similarities.
Just wait till we get into template metaprogramming.
Yeah. It's a bit like the whole Windows macOS thing. They're so similar that it really confuses me sometimes.
Now, I say this all the time to our regular students in our past C# class, but just a reminder, if you are becoming a member sponsor and joining us for the remaining weeks of this 8-week program, don't forget, you're welcome to attend all of the classes. So come hang out with us at any time. That means, we've got a UDK, an Unreal class that's going to be kicking off next week. Blender 102 is going to be kicking off, No, I think that one's going to be pushed back by another week or so. I got to check with Zach. But we also have C# 102. That's where things are going to start getting a lot more fun than what we saw in 101. It's going to be kicking off next Thursday. Go ahead.
This has only just occurred to me. Going to be trying to squeeze in open hours.
Yes, we are. And I was about to mention that.
Oh, that's right. Yeah,
and open hours will be something that we're going to be providing, except I think the way we're going to go about doing it this time is putting the open hours, making it basically for both C# and C++. So Nelson and I will be here to help people during open hours. And for those of you that are new to these courses that we're doing, it's something that we try to throw in each week. We have a time called open office hours. And it's just where we set up a webinar and you guys are able to come in and ask questions and get our help. We can jump over to your screen and help track problems down. You can ask questions in regards to, homework or, of course we try to keep it, though this almost never happens, we try to keep it related just to the content of the course that we've covered up to that point. But, the point is we are available to help you guys out. And so take advantage of that time. It's not a guaranteed thing every week, though we try to make it our, a point to provide that each week. And so far we've done really good with it, missing only 1 week, I think. And outside of that, anything else that you guys can think that needs to be mentioned? And I did see a question come in over on the questions panel from Douglas. Will we be using BuzzNet for C++ too? Yes, we are. And the URL for it is just buzznet.3dbuzz.com. And yes, the 7 o'clock will be the Friday class. You're very welcome, sir.
He's just turned up for the start of class because it's now
Yeah.
7 o'clock.
I feel bad.
Excellent.
He's coming in right as we're saying goodbye, and you guys all take care. Hey, Jeffrey says you guys should do a DirectX class. Nelson and I have talked about it several times. But we want to get through all of these beginner level classes just to get everyone up to speed so we can have more people with us. And Joseph said OpenGL, please. Well, we have done some OpenGL stuff. We'll see. Don't worry, Segfault. Unity for sure. Okay, well, let's go ahead and wrap it up. Alex had a quick question he just threw in and said, what about Java? And Nelson?
And Nelson
Yeah,
choked.
I hear that.
Oh. The answer is probably no. I don't want to. If there's demand for something, obviously we would consider it. But I want to point out that although I love Java's enumerations over C#'s enumerations, which I pointed out a variety of times, I really personally dislike Java as a language and a platform and an ecosystem.
And how are we going to do? And
Plus, even Nelson's brain can only hold 8 IDEs in his head at a time.
And Mr. Complicated said, how are we going to do Android development without Java? Simple, with C#. Using Mono.
Yeah, we're looking at using the Mono touch stuff, and of course we can always jump back into Java for low-level stuff if we need to. I'm not entirely sure about how that works with each other, but I don't think we don't have any plans for like an intro to Java class writing things out to the console, that sort of thing. If we need to use it to work on something else, then we'll use it. But the syntax is so similar to C# anyway that most people shouldn't have a problem with it.
Douglas, we're not using it this week. There is no. That's why there's no class in BuzzNet.
Yeah, free classes we don't use BuzzNet.
F# would be a really fun class to do at some point. So.
Okay, awesome. Well, let's go ahead and wrap this up. Nelson, I'm going to give you and Gavin a shout just as soon as we bring this to a close. I'll try to get this video encoded tonight, and it will go up in the 3D Buzz Lounge forum. So just keep a watch over there. And again, I'm just going to make a link available for you guys so that you can just download it and keep a copy with you. But thank you guys very much for coming out today. It's been awesome. And for those of you that will be joining us again Friday, we'll see you then. And for those of you that are going to be partaking in the 8-week course, we'll see you guys for class next Tuesday. And be prepared, starting next Tuesday, we will have homework that you will have to do every week. Thanks a lot, guys. We're out of here. Bye.
See ya.